Welcome back to the Benjy and Cal podcast, episode 9. Yeah, science, bitch.
Wow, that was the greatest intro so far.
I agree.
Yeah, so science.
Science.
We've touched on science before, but this time we're really zeroing in on it, on the thing itself, asking a few questions about it. We're going to be asking, what is science? And what is science not? And also, is it a good thing? Or to what extent is it a good thing? And we will also be asking, if anyone's seen Breaking Bad, what does Jesse Pinkman mean when he says, science, bitch?
Yeah. Yeah, so we're going to be addressing all of these questions within the next few hours of your time.
At this rate, we're adding like an hour every few episodes, so
Oh, yeah.
sit tight, people.
That's going to be induction, which we're going to talk about. That's an inductive argument, so keep that in mind, folks. So what is it? As always, we'd like to start with definition. What is it? What is it not?
Okay.
All right, so I'll tell you my definition. All sciences is a specific method for figuring out the rules of nature. Emphasis on the method part. So I know other people will define it to include other things, but that's my definition. And those other things that are lumped in there sometimes is, in addition to being a method, it's a culture of skepticism, rationalism, and atheism. And it's, in addition to that, it's the technology and the body of knowledge it produces. So everything there is considered science. So when Jesse Pinkman says, yeah, science, because something worked, just because he saw a chemical reaction in process, he says, yeah, that's science. But to me, that's something that already existed. It was discovered through the scientific method. And then now it's just like a fact that we have. It's not like every time you do it, you do that specific chemical reaction, you're doing science necessarily, because you're not doing research, you're not performing the method. You're just doing something.
Meaning, if somebody gave you instructions to put the following solution inside this beaker and then put another solution inside, and then something happened, that's not doing science because you were just following instructions.
Right. Like, I don't know, every time I make a chemical reaction, every time I bake or cook, I'm doing a chemical reaction. So, but I wouldn't call that science, although people do say it is a science. But there's some sort of line where, like, what you're doing is complex enough that people, even according to this definition of doing something that was discovered through science or understood through science, like, it has to have a certain amount of complexity to be considered science. So, if you're just stirring a pot, even if you're stirring, like, I don't know, a soup mix into water, like, that's just, at that point, that's not considered science. Because even though it's like dissolving and there is maybe a subtle chemical reaction.
Well, hold on. So I'm starting to lose sight of the definition here, because obviously science is not contained to pots and beakers and stirring stuff, right?
Mm-hmm.
So one more time, what is your definition of science?
So my personal definition, and what other people, like, not just me, but it's a method. And how does this method work? The method works by you start with some observation about the universe. You see something, and this is going to come from, like, subjective experience, because you're not just like a blank slate. You have some bias, but this is unavoidable. So you start with your observation. You say, hey, I have a hypothesis. I'm seeing some phenomenon, so I'm going to make a hypothesis based on this observation. And then you have to be able to experiment on this hypothesis. It has to take a certain form. It has to be falsifiable, meaning it has to be able to be proven false. So if I were to say, I don't know, I have a theory that, what's a classic scientific theory? Okay, when I mix these two elements, I'm going to get a toxic chemical. Okay, and the reason this, maybe this scientist working in a lab died was because he mixed these two chemicals. So that's my hypothesis.
If you mix these two chemicals, they'll explode.
They'll explode.
Yeah.
And take out the crime boss. Maybe.
Sure. Yeah.
So let's say no one's ever done this before, or to the best of my knowledge, no one's done this. So I have my hypothesis. When I mix these two things, it'll explode. That's a good hypothesis because then it's falsifiable. I can mix them. And if they don't explode, then my theory's wrong.
Did you have any reason to believe they will explode before this?
Yes. So that's part of it. It's not like hypotheses and observations pop out of non-existence. There's a subjective human experience guiding your hypothesis making. So you're not just going to say, when I add a towel to a light bulb, it'll explode. You could. That is a valid hypothesis, but the universe of hypotheses that you're going to choose from is going to be way, way more direct, way more focused. And yeah, it's just, there's no way of avoiding that. So it's not purely objective in that sense. So that's an important thing to keep in mind, because we often think of science as this objective thing, which is supposed to be. It's not supposed to care about your feelings. It's not supposed to care about how many people vote one way or another. It is a method of seeking the truth. Okay. In a very material sense. It's a method more not just about truth, because truth can encompass other areas of meaning, which is something we're also going to talk about, because that science doesn't address other issues. It addresses issues that of the fundamentals that control the universe in a way. That's also kind of an interesting definition. But how the universe works in practice.
Okay. I heard something very general and then something a little more specific. The very general thing I heard was that it's a method for determining the truth, something like that?
Yes, in a very, general. The laws of the universe for determining those.
Why do you then limit it to the laws of the universe, if that's limiting it at all? Maybe you'll explain that that's not limiting it.
Mm-hmm. So let me just first, before I get to that, let me just finish the method.
Okay.
There's also, once you do the experiment and you determine whether it was wrong or if it was in line with your hypothesis, then you do an analysis. You make sure that you followed everything correctly. And then you could say there is evidence in favor of my hypothesis. So far, it seems correct. And you have to do your interpretation. You give it to other people to review, peer review. That's a very important part. But mostly it's about saying, hey, so far it looks correct. Just because something exploded that one time when you mix the chemicals, it's evidence in favor of your hypothesis. It hasn't proved it correctly because maybe you missed a variable. Maybe there was a secret chemical hidden in one of the other chemicals that really created the explosion.
Mm-hmm. Meaning the best you can do is to genuinely and thoroughly set up your experiment with the best attempt at falsifying your hypothesis. That if the hypothesis is wrong, I'm going to set up everything I can to try to make it be proven wrong. And if you fail to do that, then you at least have that's the best you can do. Like you have at least shown that, okay, my hypothesis failed a thorough attempt to falsify it.
Right.
And that is to say it passed. That is to say, I don't know that it's true, but it works for now.
Mm-hmm. It's looking good.
Mm-hmm.
And there's a famous psychological experiment where they ask people to, I'm going to forget the basics of it, but because I just thought of it now. But they tell people, here's a pattern of numbers: 1, 3, 5. Yeah.
Veritasium did a video about this. I thought it was here's a sequence of numbers 1, 2, 4, 8.
Okay, that's it. Yeah, sure.
And what's the pattern? What's the sequence?
Right.
Or it's really like, I have a rule regarding a sequence of numbers. I will give you a sequence that fits my rule: 1, 2, 4, 8. Now you can offer me sequences and ask if they fit the rule and try to figure it out. That's And then of course everyone jumps to what they think it is, right? That you always double it. And then they'll offer sequences that support the hypothesis. They won't try to falsify their hypothesis. They'll offer sequences that support their hypothesis. They'll still say, oh, okay, 8, 16, 32. And the person will say yes. And so they'll continue to confirm.
They'll say that, yes, it does follow the rule. Yes.
Yeah, it follows the rule, exactly. And they'll continue to kind of do this self-confirmation where they think, oh, yeah, exactly what I thought it was is it, because he keeps saying that my suggestions follow the rule.
Mm-hmm. But then they say, okay, wait, maybe it's only like even numbers besides for 1 or non-prime numbers. And then they'll say, so does like 1, 2, 4, 8, 9 work? Because that's a non-prime number. Or they'll say 10. And then he says, yes, that follows the rule. And then they'll be like so confused, because they're going to say, wait, what? I mean, that also follows the rule? And that's the point, that you could keep on finding all of these sequences that support, that follow the rule, but gets them no closer to the truth, because the real answer is that the rule is any ascending numbers.
Mm-hmm.
So in order to actually get to the truth, they would have had to play around with it and go against what their hypothesis is. So if they think, oh, maybe it's only doubling by 2, well, maybe first I should check the sequence 1, 2, 4, 8, 7, and then -1.
Mm-hmm.
And then all of a sudden he'll start saying, no, that doesn't follow the rule, and they'll start getting useful information.
Yeah, there's a big pitfall that developers can fall into, where they write a test that always passes.
Like software developers.
Software developers, yeah. Where you think you're writing a test that tests your code, but you've written a bug into the test itself, or you just didn't set up things correctly, and your test just happens to always pass. That's just the way it is. Mm-hmm. And so you write it, and then you run it, and it passes, and you think, my job is done. My test passes. That's fantastic. Like, that's what you want. You want your test to pass. But no, actually, you first want your test to fail, and then you want it to pass, so that you know that it passes for the right reason.
Right. And a lot of what they say, like I read this book by Chris Hadfield, a NASA astronaut. Whenever they're doing tests on like a new spacecraft, they want things to go wrong, because if they don't go wrong, and then later on in the actual flight, they might go wrong then, and then it's much worse. So when testing it in that phase, you want to push it. You want to make sure, like, test it under all circumstances to make it fail, so that you could target what specific issue it is and then patch it.
Mm-hmm.
Because you can never get to the point where you could prove that this spacecraft is perfect. You could only reduce the amount of issues that you could find and confine it.
We're talking about an aircraft, right?
Aircraft, spacecraft.
Either or.
Yeah. But a lot of it is reducing the amount of not ignorance, but unknown. Reducing the unknown. That's what science is. It's about reducing the picture of what we know about the universe and constricting it to be less of the unknown, more of the known, and never about it's all about convergence. The process converges to somewhere, but it doesn't just get you there immediately.
Mm-hmm. So actually, when I was preparing for this, I like that, by the way, the reducing the unknown. It's very similar to what I wrote. I thought about it for a little bit. I also went in kind of a direction about like, okay, the physical world, the natural laws, but I think there was something more fundamental that we've just touched on, and I wrote that science is the disciplined pursuit of knowledge. And then I said, in other words, science is the fundamental claim that there is so much that we do not know that could be known if we applied the required effort to knowing it.
Mm-hmm.
Meaning, it's sort of sitting there and saying, okay, how far is it from LA to New York? And you can sit and speculate about it, and you can say, okay, well, I know it's far, but you don't know exactly how long it's going to take you, whether by carriage or car or plane. And science is realizing that, listen, we actually could know the answer if we just put in the effort, if we just measured it, if we just decided, okay, we're actually going to know the answer and we're going to use something we are familiar with as a reference point. Like everyone knows how large a foot is or how large an inch is or whatever. We're going to use that as our reference point, and then we're just going to measure and count up how long it is. And it's just, science is that claim that there is so much in the world that can be understood if we just go out and understand it.
Mm-hmm. So that leads to some of the questions that we're going to discuss, because one of them you had mentioned is, what does it mean by truth? What do I mean by pursuit of truth? What kind of truth does it actually reveal? The other one is, like you're saying, it's a matter of go out and test it. Just do the science.
Mm-hmm.
And that leads to the question of, why don't people do this just intuitively? Why did it take so long for mankind to get to the scientific revolution? What was holding them back? So why isn't it just a natural thing?
Well, can I push back on the premise a bit?
Yeah.
Okay, so I actually do think we do this intuitively. I can't speak to the historical complexities of the Dark Ages and the scientific revolution, why it happened when it did, and why it didn't happen earlier. But I do claim that people were doing science well before the scientific revolution, and that children do science. They just don't necessarily call it that, but we do have a very strong intuition for science. I thought of an example of a child who loses a tooth, and he, let's say he has some random idea to put it under his pillow, or let's say his parents suggest putting it under his pillow. For whatever reason, he puts it under his pillow, and in the next morning, under his pillow is no tooth. Instead, there's $1. That's how it happened for me. I don't know if there's some variations on exactly how it happens for other people. But anyway, so the kid, even by the way, when you tell him that it's the tooth fairy, right, there's still a lot of curiosity there. The kid will have questions in his mind that he might not even necessarily voice, but he's kind of like rolling it in his head, and he's going to experiment it. He's thinking, well, does this work every time, right? If the next tooth that I put under my pillow, will it also become $1? Does it work even if it's not my own tooth? Does it work even if I'm sleeping over at my friend's house? It even happens where kids will lose tooth in unique circumstances. Maybe their family's on vacation and they lose a tooth, and they're thinking to themselves, wait, does the tooth fairy come if you're on vacation? And it is the scientific method. They observed a phenomenon, they asked a question about it, and then they have a hypothesis, and they have a way of testing it. They say, okay, well, if come morning there's $1 under my pillow, even though I'm staying at a hotel with my family on vacation, then I guess the tooth fairy does come when you're on vacation. That sort of thing.
So I hear what you're saying about maybe coming up with the questions.
Yeah, but even the experiment.
Do they do the
experiment.
Science? You as a kid did the science. You said
it's science as it's science for a child. It's the child is saying, my experiment will be, I will put my next tooth under my pillow, and I will observe what actually happens. Then I'll know that, okay, it didn't just happen for the first tooth. And I might run the experiment. He doesn't call it that, but I'm saying it's basically it's running an experiment.
So you did this as a kid.
Well, not everything specific that I've been saying so far I did as a kid, but the concept, yes. I certainly speculated about what.
Oh, you speculated. So you didn't do the science.
Well,
and also, I think you're talking for a lot of kids here.
Yeah.
I think most people would say, I don't know, that they didn't necessarily think. Maybe they wondered as a child, like, oh wait, who is the tooth fairy? Like, I think a lot of kids just assumed the tooth fairy was real until their friend told them it's not. And then other kids might have said, oh, it's, maybe some kids were like, oh, I think it's my parents. But I don't think many kids would like say, okay, I'm going to run an experiment, a controlled experiment. I'm not going to tell my parents about it.
Mm-hmm.
And I'm going to see if I get money anyways. Maybe I did that once. Actually, now that I'm thinking about it, I did it without telling my parents and I didn't get anything and I was very sad. But
there you go.
But I don't know if I went through the whole process.
Well, that's what I'm trying to say is that you don't necessarily know you're doing the process. I'm saying there's a strong intuition for the scientific method. We observe things, even as kids, and we ask ourselves, well, is that going to work again if I do it a little differently? Is it the tooth that was special? Is it my pillow that was special? Is it just this one-time event? That sort of thing. And we do then let the events play out and observe them and then modify our hypothesis or reject our hypothesis based on the conclusions of our test, which was simply, the next time we lost a tooth or whatever.
Okay. I'm still going to push back a bit on this because I think that people think about it, people speculate, people are always asking questions. That's not a question. It's always been, okay. Mankind has always been looking at the stars, asking like, why? Mm-hmm. Why does this do that? Why is it?
Yeah.
And okay, they come up with hypothesis, and that's exactly what like the tooth fairy is. It's this imaginary explanation that isn't actually scientifically sound that you could like convince people to believe in. And so these things are things that, explanations. For the longest time, we believed in ghosts. We believed in the paranormal. And we didn't do the science. We just, the laziest, most efficient way was to accept the explanation because we ask why. Here's an explanation. So we just accept it. And then we think about stuff, but we don't test it. We don't do the science intuitively.
So I do agree that one of the obstacles to scientific advancement through human history was that science is difficult and requires more effort or tools or means. And
patience and education.
Yeah. I'm in the middle of arguing that it doesn't require that much education because I think that the intuition is there, but many people throughout history stopped at the point where, okay, I kind of have I have an idea of what it would take for me to measure the distance between, or let's use a different example because we're talking about the older world. I have an idea of what it would take to measure the distance between Rome and Athens, but obviously I'm not able to do that. I'm not able to then like line up sticks from Rome to Athens and count how many sticks it took to get there. So there was an obstacle of difficulty. And of course, humans were preoccupied with other things, or there was not enough reason to invest that much effort. But the intuition is there. And regarding the tooth fairy, I want to clarify something very important. It's not about the explanation of how the dollar got there. It's not. Meaning the tooth fairy is not the hypothesis that I'm talking about. The tooth fairy as a hypothesis is not a very scientific hypothesis, especially because, as we're going to talk about, it is not the simplest hypothesis given the evidence.
It's also easily falsifiable.
Easily falsifiable? I actually was thinking it's not falsifiable.
It's not falsifiable. That's true. You could always come up with some, the tooth fairy snuck in, during that microsecond.
Or you could say it's invisible.
But you could also just put so a tooth fairy that only comes when you're not looking is unfalsifiable. Mm-hmm. But a tooth fairy in general, if you say, the tooth fairy exists and it comes and it takes your tooth, gives you money, well, you could just put a camera up, and if it doesn't come, can you conclude? Yeah, it depends on your definition of the tooth fairy.
Yeah.
If this isn't an omniscient tooth fairy, which I guess we assume it is, because how would they know you lost a tooth? They must be pretty darn powerful
Yeah.
and know everything. So yeah, okay. So it's not very scientific, but it's also not easily falsified.
Yes. But anyway, the tooth fairy itself is not the hypothesis I'm talking about. Whether or not the kid thinks it's the tooth fairy, that's not really. I'm talking about just how things work, right? The kid just sees on a base level that he lost a tooth, he put it under his pillow, and he got $1. Regardless of exactly who did that or how it happened, I think what he's really interested in knowing, if I put myself in the mind of me as a kid, is that the tooth fairy is kind of irrelevant, right? It's kind of like, okay, whatever, it's the tooth fairy. What I'm really interested in knowing is, what if I convince my friend to give me his tooth and I'll put it under my pillow? Do I get $1 then?
What if I make a fake?
What if I make a fake tooth? What if I lose 2 teeth at the same time and put them both under my pillow? Do I get $2? Things like that. And all of that is very scientific thinking. All of that is a question about a phenomenon that was observed, which immediately turns into some sort of hypothesis, which immediately turns into some sort of test, even if the test doesn't involve actually doing anything. It's just waiting for the circumstances to arise again that fit what I want to know. The intuition for science is still there. That's all I'm saying.
Yeah, but I don't know. I think the test is the whole point. It's the whole essence of the science.
Okay.
Because otherwise you could come up with all of these phenomena that have explained things forever for humans, and we've been satisfied with it, but because we never did the test. So also, do you know how they wound up measuring the distance of the world? Or
No.
large distances?
No.
They would take the length of a shadow.
Oh.
And at like noon at one location, and then like a few kilometers in different location, or they would notice that like the angle was slightly different. And because the Earth is spherical, that's why the angle is different, because the sun is hitting it at a different like if you have a pole sticking up in the northern hemisphere, the shadow is going to hit it at an angle pointing upwards, versus in the southern hemisphere is going to point downwards.
Yeah. And
so that discrepancy through trigonometry gives you an estimate for the distance. And they were off, but they weren't that far off. That's how they calculated the circumference of the Earth.
That is really cool. I actually did read about that once, and I forgot about it. I'm impressed you remember. But yeah, I read about that in a book called The Art of More by Michael Brooks. Good book. History of Mathematics.
To play on the art of war.
Exactly.
Interesting.
Yeah.
So back to what you were saying, I agree that there is some intuitive playing around with stuff, instinctual, that we're born with. If you look at kids, animals, they drop things, to see if this thing will break. Very, very physical science. They want to test object permanence, if like when I look away, if I turn back, it's still there. If it's, when I push this, will I get a reaction? So part of science that we don't really talk about is just the messing around, because we often think, it follows this like very strict regimen. I have to come up with a hypothesis and just and then test everything, but that's not really how it happens. A lot of the biggest scientific discoveries were accidental. Some chemist working in his lab testing one thing, and then all of a sudden he looks at his other experiment that he screwed up, and it's all of a sudden he wanted to create a better gasoline, but now this thing is super sticky, and he created super glue.
Nice.
So then he said, oh wait, I'm already at the observation part. Whoops, I already did I'm already at the experimentation analysis part, because this looks like I created super glue. So I'm just gonna go back and formulate my hypothesis and say, maybe if I mix these two compounds, it'll work. So it doesn't follow this always start at an observation and only then interact with the world. It's a loop. It's a feedback loop. Once you do we call that the experiment that something went weird, and then he goes back. Now he makes a more formal hypothesis saying, okay, I know that something about these chemicals makes superglue. I got to figure out, though, which ones. So now I'm going to say maybe it was this chemical and this chemical. And then he tries to repeat it. Doesn't happen. So it's something else.
Mm-hmm.
And that's also a very important part of it's got to be repeatable. So you have to really, you can't just discover something. There was something, was it batteries? I think there was, or superconductors. I think some scientific paper discovered room temperature superconductors, which, by combining this certain type of graphene and whatever, you create a superconductor, which means that it conducts electricity with zero resistance. And we have that, but at 0 degrees Kelvin, which is the coldest that anything can be. If we could get it to room temperature, then this would be huge. Then, we wouldn't have to worry about resistance with anything. Things wouldn't overheat. Electricity would be super efficient. So this was a huge discovery a few years ago, but no one could figure out how they did it. They didn't put a clear recipe. And when they did, people just couldn't replicate it. So then it was determined that they were something was weird, and they made something up.
Mm-hmm. So about repeatability, meaning it's clear that things need to be repeatable in order to persuade other scientists, other skeptics. Is it intrinsically a part of science, or is it just practically, in order to persuade anybody that your findings are legitimate, you have to be able to repeat it? And the other question is, is repeatability a practical concern or a theoretical concern? Meaning, and that kind of connects to the first question, because if it's just that it practically needs to be repeatable, then it seems to me that it's just, again, practically you need to be able to persuade other people. But if it's theoretical, meaning, let's say I have this special gem that has never been seen. It's from some other world or something, and it just came, and I made a number of observations, and I ran a number of tests on it, and I documented all of it. But then it disappeared because it went back to its world. The spirit who brought it into this world took it back or something. So now we don't have it anymore. But I ran a lot of documentation. I ran a lot of real experiments and documents about it. I understand that, practically speaking, for the purpose of science that is shared with the world and documented for the world and of great concern to other people, this will probably be ignored because everyone will say, okay, well, we can't repeat it, so we can't really treat it as science, and we can't study it ourselves. But fundamentally, intrinsically, has this person done science even though it was never repeated?
So he has followed the scientific method, as you said, but because it's not repeatable, it's basically useless. It's not real science, which I think you're proving exactly why. You're demonstrating exactly why repeatability is so essential to the method. Because science is about discovering the laws of nature, the laws of reality, and allowing us to use these laws of reality to apply them. And if we can't use them, if we can't demonstrate them, then though you've followed the method, you haven't actually revealed anything about the world, because we'll never see this block again, this meteorite again. If there's a chance that we'll see it again, fine, but it's dependent on that meteorite.
So I'm not sure my question was fully answered, though, because you said that science is a method. This person has followed the method, but it's useless to everybody else.
Right. Well, science is a method, and it also has to be repeatable, I guess. Maybe I'm extending it a bit.
Okay.
But let's say you're working for the government on an NSA or something, and you've discovered, I don't know, or it doesn't have to be the NSA. If you've discovered something in private, is that science? Well, if it could be applied more than just to you, more than just like a blank, like an empty square, more than just an empty room that you've applied it in. If other people are applying it, then it's repeatable and then it's more useful. I don't know. It's an interesting thing to think about. And I wonder if it's only a theoretical case or if like this, if the NSA top secret government thing is a practical example. I know a lot of scientists get upset when people hide their results because they say that's not in the spirit of science.
Mm-hmm.
So maybe repeatability and reproducibility. I don't know. It seems so essential to me, but I'm wondering if it's just the spirit of science versus science.
Well, I would add that it's not just the spirit of science, it's a practical necessity for science as it's applied in the world. But I think fundamentally it's not necessary to science.
Well, it just seems to me that if I come up with a law or a theory to understand the world, and this theory can never be applied in any situation at all, then I haven't come up with a theory to understand the world.
Well, it can't be applied because the gem was taken back to its other world by the spirit, meaning it can't be applied practically by anybody now, but theoretically it could be. If the circumstances arose again to allow us to apply it, it could be applied because it is legitimate as a observation of reality, but practically because of the time we live in, because of the place we live in, whatever, practically nobody can use this or reproduce it.
Right. So yeah, I would agree with that. That's why I had qualified before. I'd said if there's a very small chance, as long as it's not non-zero, that it will be repeatable, then it would count.
Okay.
But I don't know. Let's say you find this really ancient magic textbook, okay, and it had a whole bunch of spells and stuff. But you knew that, like in the first page, it says, "Oh, by the way, the magical age has passed. None of these spells will work anymore." But take my word for it, they once did.
Well, this is the beginning of a young adult fantasy movie, where obviously then the whole plot is about restoring the magic of the age that has passed. Mm-hmm. So,
right.
In theory, it's possible that it could come back.
Right. Okay. But we know that it's not, and we know that, like, if we found such a book, we're not just going to say, "Oh, well, you said that it worked back then, so we'll take your word for it, and we'll just have to wait till it comes back."
Right.
We would throw that out. We would say this is unfalsifiable.
Mm-hmm.
It's not science.
Well, we wouldn't throw it out.
We would label it pseudoscience.
Yeah.
And
we would, yes,
push it into a far corner where we know it exists.
Well, here's the thing. There's a lot to study about things that are false, as long as either people believe them or even just the fact that somebody wrote it. Meaning, a mistake that excuse me for a second, Richard Dawkins. A mistake that Richard Dawkins makes, although I think sometimes people have...
Do you want to give an intro to Richard?
Richard, Professor Dawkins, I think he must be a professor. He is an atheist, an evolutionary biologist. I hope I got that right.
Yeah.
You probably know more about him than I do. I've heard him speak on YouTube a few times. That's basically the extent of my awareness of him.
I started The Selfish Gene, which was his big famous book, but I didn't get far.
Okay.
It's very technical. And biology is not my strongest suit.
Okay. I'm surprised by that, actually.
Yeah?
Yeah.
I mean, out of all the sciences, I think biology is, I don't know. I'm working on it.
Okay, yeah. So I think one of the mistakes that I have heard him make, but who knows, maybe he's come around on this because I've heard some people kind of prod him about this. I've heard him speak about the Bible as if, it's, we could just throw it out. It's useless. You might as well just be reading Dr. Seuss.
He actually has a very, you know, what's the word? Angry, not angry, but like harsh criticism of the God of the Bible. He goes on like a whole rant of like, this is a God that is genocidal and just terrible, kills people and tortures them, and he goes on a whole thing.
Yeah, but yeah, the point I'm zeroing in on is that he will belittle the Bible as if kind of like it's not scientific, it's not historical, it's not true, so we can just throw it out. There's actually obviously a mistake there, because from a sociological perspective, right? Even if we were going to say, okay, this is not in the realm of science, all right, we're not going to classify it that way. Don't throw it out, though. It's definitely sociologically the Bible. There's a lot to study there.
Historically, there are parts, at least later, that are.
Oh yes. Also, it is.
He really said it's just absolutely historical garbage, or
so all fairness to Richard Dawkins, I don't have a direct quote in my head right now.
But we will have him on the show in future episodes.
Yes, he can defend. He can say that I never actually said that. Yeah. But let's not say Richard Dawkins said this. In my mind, I believe I've heard him say that. So let's just imagine a hypothetical person saying that, and it sounded like you were close to saying something like that. So, meaning you can study things from other perspectives than a scientific perspective. Obviously, a document that large numbers of people hold very dearly, study, analyze, that was compiled over many years. Obviously, that document has historical significance as a document. It is evidence of something. It is evidence of what people believed, what mattered to people, what inspires people. It's evidence of all those things, even if it's not necessarily an evidence of historical fact or of scientific fact. So that's all. So that would go the same for a magical book claiming that there's magic and there are spells, and that wasn't, and is clearly not being ironic and clearly not being fictional, but actually just claiming this for real. Even if we say, okay, we're not going to accept this as scientific fact, don't throw that out. That's something that...
Right, I didn't mean like burn the book. I just meant throw it out from a scientific perspective.
Gotcha.
But yes, there's so many aspects to life that don't include science. And we sometimes overestimate, maybe overvalue, and the amount of the effect that science has had on our life, and that on the influence, and that gets us to one of the big questions which you had raised before. What is the truth that science tells us about? What does it help reveal? And there are things like you were saying, people like reading fantasy. People like being part of community. There are all sorts of sociological aspects that aren't scientifically, taken apart, analyzed, and also can't be for a lot of them.
Yeah.
So there's something specifically that I want to focus on, which is what is good. What is good in life? What is good in what is meaningful? What is, or when just doing a task, what is not just optimal, because optimal means you have a given goal, and what is the best way to reach it. It's about setting the goal in the first place. How do you get there? How do you define what is the best goal? And that's not something science can help with. It's not something that science addresses because it's just a method, like we said.
Mm-hmm. In fact, if we go back for a second to what we were so our kind of fundamental definition of science itself is predicated on a value statement that knowledge is good, that curiosity to discover more about the world and the effort, the investment that it would take to discover those things in a structured, disciplined way, that all of that is both possible and valuable.
Mm-hmm. And there are lots of parts of science that you follow it, even if you say that knowledge is good, it's not always good. Even that is, science is a double-edged sword. It'll give us things that are good and bad. Nuclear weapons have their good aspects and their bad aspects, as they seem to come up in every single episode.
Yep.
In Breaking Bad itself, the show, very scientific people.
Mm-hmm.
Heisenberg, very, scientific mind, follows the method, wants to expand his knowledge, and Jesse Pinkman wants to expand his scientific knowledge to become more efficient, to become...
Well, do you think Jesse wanted to expand his scientific knowledge?
To be honest, I didn't watch it from start to finish.
Okay.
More just in chunks and YouTube shorts.
The truth comes out.
That's how I consume most of my content and media these days. But from what I saw, I think he did, maybe not outside of chemistry, because he didn't care much about anything that wouldn't help him. It was just about what would help him achieve his goal of making more money.
Yes.
And if he wanted to be able to cook the finest meth, so that's something that he was interested in. And he started following all of the scientific research catalogs or journals, sort of, or at least he followed Heisenberg very closely, his mentor. At the beginning, when he was just introduced to the show, he was adding like spicy chili into his thing, and he was creating an inferior product because he didn't care. He just wanted to do it. He was using the wrong beaker flask. And then...
Okay, so Jesse wasn't really the guy who was making the meth.
He started making meth. He was the one that introduced Heisenberg to the business. Heisenberg he was suffering from cancer. This is the first episode, by the way.
Okay.
So it's very hard to say that there are spoilers here.
No, yeah.
But yeah, spoiler alert, I guess.
Uh-huh.
So Heisenberg wanted to make more money to pay for his cancer treatment. So he turned to Jesse, who had already been cooking meth, and said, hey, we could do this so much better, so much more efficiently, better meth, more producers, more money.
Yeah, I don't even remember that Jesse, even before he met Walter White, he only goes by Heisenberg much later.
Right.
Even before he met Mr. White, I don't remember him actually being the one to cook any of the meth. Yeah,
he used to cook meth. He was part of a lab. Yeah.
Well, he worked for a group that was selling drugs. I don't know if that means he was cooking them.
He was the cook.
He was the cook.
Yeah.
Jesse was the cook.
Yeah.
You remember that?
Yes.
Okay.
First episode.
I'll take your word for it.
Right.
But once he joins up with Mr. White, Jesse doesn't cook the meth. Jesse
assists.
Yeah.
And then in later episodes, he does do the whole process himself.
Yeah.
And he's followed Mr. White's influence and has created very, very good meth.
Yes. There's a scene much later in the series where I forget how this builds up to it, but Jesse is with the
mob.
the cartel from Mexico. One of the
spoiler alert.
Yeah, one of the really baddies, the bad guys, and he demands that Jesse make the formula, and Jesse pulls it off. Right. Or I think there's an earlier scene where Jesse makes the formula as well because he just memorized everything Mr. White did. Yeah.
But the point is not just, okay, Walter White was educated in the scientific manner. Okay, fine. He was already had the scientific way before he started cooking meth, so fine. He didn't get into science to cook meth. But Jesse specifically did. He specifically realized the value of following procedure, scientific understanding, and applied it, taught himself, all for not good necessarily purposes. That's the whole point.
That's the whole point. Okay.
The whole point, he says, science, bitch. And it's not, he loves science, but it's not necessarily for a good thing. He's making meth, which is addicting. It destroys people's lives.
Right.
Right. We're going to assume selling meth is not a good thing. We're not going full libertarian right now.
No. Yeah, we'll take that. Yeah.
We'll take that.
Yeah.
But Walter White used science to kill many, many people who they weren't necessarily the best people, but they weren't deserving of death. It's pretty much agreed in the show that Walter White, he even did kill some innocent people. He's not a good person, but he's very scientifically minded,
right?
And is always expanding his knowledge of facts.
Right. So all of this is to say that science can be used for bad, right?
Yes.
Science doesn't, just because you're doing science doesn't mean you're doing good for the world.
Right.
Okay.
And it's just completely independent. It's like math, Is 2 better than 3? No, it doesn't make any sense. The question is just, it doesn't fit in with the whole model.
I completely agree. Mm-hmm. My dad always used to say that science is a tool.
Exactly.
And tools can be used for bad or good.
Mm-hmm. So what I want to talk about a bit is the problem with that. I think a lot of people nowadays, there's a bit of a scientific revolution, pushed by Bill Nye the Science Guy, Neil deGrasse Tyson. Really, it started with Carl Sagan in the 80s with his documentary Cosmos, and just pushing the importance of science and how it's just the greatest thing ever. And it was kind of like a false, not false, it was a narrative that was kind of problematic. Everyone just ate it up, which is good because on the one hand, and if you watch Cosmos, it's this whole, which I highly recommend everyone. I didn't watch the original series. I watched the reboot with Neil deGrasse Tyson. But a lot of it is about how religion was bad, how it oppressed people with different voices and theories on how the world worked that were, subject to the Inquisition for voicing their opinions. How religion is just, it spreads ignorance. It doesn't spread, theories that actually make sense, and it's kept us in the dark ages. Science is the light. It's the beacon of hope. We just got to toss out all religions, societies, cultures. What you have is the scientific culture. That's good. We all have to, there's wonder in science. There's just an appreciation that as you learn more, the happier you'll be, which goes against the whole idea of ignorance is bliss, and as well as, being part of something is what makes humans happy, not necessarily knowing everything. Like the science of happiness, or I put in science there, but the way to reach happiness is not necessarily something that's subject to the scientific method, in my opinion. There is a science of happiness, a positive psychology, how to make people happier, but it's a very
has it worked
tricky.
Though?
Has it worked? You say that because we're not all happy, then we don't know. I think that they've probably done some good research, probably trying to see, hey, when people take antidepressants, it does work, maybe for a time, maybe but it doesn't really necessarily solve their issues. Maybe it'll just make them catatonic.
What does that word mean?
I'm pretty sure it means just out of it. You could just have meth and you'll be happy or heroin, inject yourself. It depends what your goals are. If your goals are how to make everyone in the world happy forever, just heroin everyone. Never let them come down. But that's not the goal.
Well,
the goal is
that doesn't even accomplish that goal, right?
Yeah, it would. If people don't come down from their heroin episode and you just hook up everyone to heroin.
I disagree.
Maybe maybe it'll stop having an effect after a while, but you can't. How could you disagree? If we define happiness as the dopamine rush in the brain.
Well, I don't define it that way. But
okay, so under the definition of dopamine rush, it is. But it does solve it. But that's the thing, that happiness is something that, we don't even know what it is. Is it long term? It's, there's this hedonic treadmill of we're always running to get what we want, and that's what we want. We don't want to actually get there. We don't want to just be covered in pleasure all the time, because then that also affects us and makes us catatonic, or just we're not able to. We become immune to the effect of these things. So it doesn't really even work as a science, because we can't even agree on a definition. It would be a science if we had a definition and we said, okay, how can we reach this? Let's research ways to optimize this.
Okay.
So yeah.
Well, I almost forgot for a second that you did start this whole thread by saying that you don't believe that science has accomplished happiness, meaning you don't believe that the scientific method will necessarily get you to happiness.
Right. But it's more that it just doesn't even address it at all. So
because you could scientifically increase certain chemicals in the brain that might make people feel good, but it's not actually giving people happiness.
I guess I'm a little back and forth there.
Okay.
As I said, it doesn't. The point is, yes, you could investigate happiness as a phenomenon scientifically, but it's all based on your assumptions. And the assumptions as to what is good, what is happiness, what is something that we should strive for, how do we define it? Those are things that can't be defined by science. Those are things ultimately that we have to decide as humans.
Yeah, no, that I accept, because I think what happens, and I think what has been happening, is that even if you say, okay, I'm defining happiness as dopamine. Dopamine is the happiness brain drug. So I'm just going to increase dopamine. If you do that, if you just focus on optimizing dopamine levels, you will mess people up, right? Like you will create highly dysfunctional people that aren't happy.
And are just addicted to looking at their phones all the time.
Yeah, and don't produce anything, or aren't constructive. And that, any normal person will, if they go down that experiment for an amount of time, I think will eventually say, okay, something is wrong here. So I was wrong about my initial assumption. Why do they say that? Well, it's not really scientific. It's scientific in the sense that they're kind of observing a phenomenon. They're observing, okay, did people get happier? No. How do you know that people didn't get happier if you were defining happiness as dopamine? And that's exactly what you have optimized. Well, because it's something much deeper that tells me that I know now that my initial assumption was wrong, not really for a scientific reason, but because there's some deeply embedded human psychology that allows me to understand other human beings, and I know that these human beings are not happy. Or I'll phrase it this way. I at least know that I would not want to be any of these human beings that I have optimized dopamine levels for.
Exactly.
Mm-hmm.
Said it very well. So I just want to talk a bit about this book that I read. It was called Zen and the Art of Motorcycle Maintenance.
Mm-hmm.
Maybe some of our viewers are familiar with it. It came out in the 70s. It's kind of had this resurgence, I think, lately. And it was written by a guy. He's on a road trip with his son, and he's just talking in his head or whatever about what does it mean to have quality. What is the quality in things? What is the good? He talks a lot about the importance of like good motorcycle maintenance. So not just taking it to the garage, but actually being one with the motorcycle, one who understands every time he hears something what's happening, who goes through the process every day of of tuning it, and then if there is an issue, he knows how to analyze it, get at the core issue. He's gotten so connected through experience with his motorcycle that his work just becomes quality work when he works on it. So it arises out of interaction and experience, and it's not something that can really be defined as to what is the best, what is the best way of doing things necessarily. It's something that like you have to reach it through experience.
So there's a term in psychology that I think can be applied here, and that's a flow state.
Mm-hmm.
Is that what we're talking about?
Sort of, yeah. That's what he gets into. That's how to like arrive at it, according to him. And it's still a bit vague, but a lot of what he talks about is so that's how to get there. But what is it? What is quality, and how important it is to everything? So towards the end, he really delves into it, and he discusses how the idea of believing in the good, that the good exists and we could figure it out, is something that was argued between two worlds of thoughts. On one side you have Socrates, Plato, Aristotle, all the big names, and on the other side you had the sophists, and the ones who won out and wound up laying the groundwork for the intellectual world for the millennia to come were Socrates, Plato, and Aristotle, and the sophists were seen as not rigorous. They were dismissed.
This is where the word sophistry comes from, isn't it?
I think so. It's kind of a negative connotation.
Right. I just lost a lot of respect for that word, because I didn't realize that, like the word itself doesn't mean, I don't know. Where does the name sophists come from? Meaning, if sophistry comes from the fact that people who believed in the good as opposed to the true, if it comes from those people who were called sophists, I'm wondering what that name comes from. Anyway, what I'm trying to get at is the word itself doesn't mean lacking intellectual rigor.
Right. It means right. Well, it doesn't mean intellectual rigor. I thought sophistry, the negative connotation means, oh, they know what they're talking about. They think they know what they're talking about when they actually don't, or something.
Okay, yeah.
They think they're so smart, they overestimate their intelligence. What a sophist is, according to Google, is a paid teacher of philosophy and rhetoric. So it's important, the rhetoric part. And okay, according to this definition, it says associated in popular thought with moral skepticism and specious reasoning. Specious. I don't even know what specious means.
It means not logically sound. Pretty sure.
Okay, yeah. So it kind of goes against how the book portrays it, because the whole idea is that on one side of the aisle you have Socrates, Plato, Aristotle. They were all about, according to the book at least, logical, skeptical reasoning. They spoke about the dialectic, which is, and that was what they're all about, having a conversation and logically analyzing everything the other person says and cross-examining it. And they were very also into science, at least in theory, even though their actual practice science was not good, because Aristotle believed, that the four elements of the world were earth, wind, air, and fire.
But what do you expect from him?
To, I don't know, test it. I don't know, see if... It seemed to me, it seems that he just looked out and observed the world and came up with these hypotheses. Oh, everything that I see is either earth, wind, dirt, earth, wind, air, fire.
Water.
Did I not?
Wind and air are the same thing.
Yes.
Earth, air, water, and fire.
Yeah.
Okay.
So how did he arrive at that? He just said, oh, I don't know, it just seems that anything that can be burned, I could reduce to fire. Anything that came out of the, I mean, technically it might be true according to his definition of what Earth is, but because he took it as fact without being able to like prove it rigorously, it seemed that it was just like his theory that that everyone just accepted, but without any. I don't know. I don't think there's any physical experimentation done and recorded with this theory.
Well, it depends how the theory is used, of course, to determine if it really was, the more that a theory is used for, the more it needs to be tested rigorously, right? But if it's kind of just a way of organizing, I mean,
he also said in the universe, everything outside the sphere of Earth is ether. That's just a mysterious magical substance that exists. Okay. That's not a scientific definition. That's unfalsifiable.
Yeah, I mean, I'd have to understand the context in which he said these things. Going back to earth, water, air, and fire for a second, he probably wanted some way to classify the fundamental. Right, he didn't yet understand what an atom was, or he didn't have any yet. He didn't yet have any knowledge that atoms.
There were atomists, really, in ancient Greek. Yeah, in Ionia, I don't know.
Wow.
But there was someone who said, "Hey, logically, it does. If I could keep breaking down everything into smaller pieces, it makes sense that at some point it just stops, and there's like some indivisible." Form of matter that it can all be, you can reduce everything to atoms, which is what atom means. It means indivisible. Now, they might have been right in a way, but it wasn't scientifically sound when they proposed it because they didn't really test it. They came up with this theory, but why not? Why can't the world just be divisible into smaller chunks? I don't know if they really like gave a really convincing argument. And also atoms anyways can be split. There are smaller things than atoms. There are quarks, and then quarks themselves are made up of fundamental particles. Those fundamental particles are just made up of energy, so they're not really divisible at some point. So they were sort of right. But they didn't know that they were right.
I thought you just said the opposite. I thought you basically just explained that there are smaller things than atoms, and even those smaller things can be classified on an even smaller level, which is that they're just made up of energy.
Yeah, but as far as I understand, like quantum and theoretical physicists would agree, like they call it fundamental particles because there's nothing really smaller. There are smaller distances. There's like the Planck distance, which is smaller. But in terms of matter, like just that's the smallest matter can be. Otherwise, it turns into energy, which is, I don't know, a different way of looking at it.
Okay. I mean, yeah, if you want to qualify it as it's the smallest matter can be before it becomes something else.
Right. We'd have to consult. That's a very. It's also like on the fringes of quantum and theoretical physics. So I don't know. We'd have to consult an actual expert to ask them if things are infinitely divisible, if we know, or if the question doesn't really make sense and it depends how you think about it.
Okay. Yeah. Let me offer that a lot of scientific knowledge ends up being kind of the way the knowledge body has formed for human beings, and there ends up being kind of like certain things that are just taken as, yeah, this is the way it is, even though in reality it's not that way. But because for practical purposes, excuse me, it's almost always that way. We'll all just continue saying that is the way it is. But when we really get down to the reality of things, it's not really that way. And I feel like that happens a lot, and it's sometimes relative as to how those things arise. Because something that just came to me now as we were talking about atoms is, the movie Ant-Man?
Yes.
Marvel. I saw the first one. I never really saw any of the other ones. But from what I understand, he can do this thing where he goes into the atomic world.
Because most of the space between atoms is empty space.
Okay.
So it's just about shrinking that space, which is...
Of course.
Yeah. I mean, technically, from a scientific perspective, you could shrink Mount Everest down into something you hold in your hand. I think that would have the density of a neutron star, which is like the densest matter in the universe. And so you'd be holding Everest in your hand and it would crush you and, I don't know, create a black hole or whatever.
Mm-hmm.
But it's possible because you can compress atoms that much because there is that much empty space.
Okay.
But a human being, obviously, if you crush down atoms into the space between them, then they become something else, and you can't sustain yourself as a human like that.
Uh-huh. And there's a lot of empty space in atoms.
In the atoms as well.
Yeah. So
most of it is empty space. Like if you were to scale it up, it would be like a pea in the middle of a soccer field or something, or maybe a soccer ball.
Yeah.
That's the nucleus compared to the electron outer orbit.
Yeah. I had a science book that said something like the nucleus, if you scaled it up, the nucleus would be the letter O on this page, and the atom would probably be the room you're sitting in, or something like that.
Yeah.
Which is also interesting. There's a few things that I want to say here, but it's also interesting that we say the atom is the smallest thing, except for, what are they called again? Quarks. But then there's also parts of the atom, like the electron and the neutron and the protons.
Those are no. Neutrons are made up of quarks.
Okay. But
An
why?
Electron, yeah. What?
Meaning a proton is obviously smaller than an atom. It's inside the atom.
Yeah.
So what is a proton?
It's a more fundamental particle.
Okay.
Than the atom.
Okay.
The atom is made up of protons and electrons and neutrons.
Okay.
And those are made up of quarks.
And so let's go back to Ant-Man for a second. When Ant-Man goes into the atomic, I saw the first movie. I don't know if he ever goes into the atomic world in the first.
He does. Oh, in the first? No. I don't know. Maybe.
I don't remember him doing it.
Okay.
So what happens when he goes into the atomic world? Is he inside atoms? Is he in between atoms? I'm asking. This is part of my point. I need to.
I don't know. Let's say he's between atoms.
Whichever one he is, even if he's in between, but certainly if he's inside, I wouldn't think that Ant-Man himself would continue thinking of atoms as the smallest thing in the world when he is now as small as them. And he's now able to observe the smaller things than them. And especially if we then imagined a lot of Ant-Mans and imagined a bunch of scientific Ant-Mans who then studied the world from this perspective for many, many years, I can't imagine the scientific body of knowledge that they develop containing any statement akin to the atom is the smallest possible thing. It's the irreducible unit of the world. They wouldn't contain any statement like that, I would imagine, because the atom is now it's like a planet.
Right. So you're kind of arguing that there must be atoms all the way down. It just keeps getting smaller and smaller.
Well, I'm not really saying that, but maybe there's a lot more to discover in the infinitesimal, in the super miniature. Maybe, right? I've heard it mentioned that the ocean is less explored than outer space. There's so much more to understand of the ocean on Earth. There's obviously so much more to understand of space and the universe. Maybe there's also so much more to understand of the super, super small, right? Of the things smaller than atoms, of the things smaller than quarks and protons and neutrons or whatever. So that's all. Yeah.
Yeah. No, I hear you, because it's kind of weird that, the human scale is it feels like it's somewhere in the middle, because you go up, by factors of 10. It's all logarithmic. You 10 times the size of a human, buildings, 10 times that, countries, 10 times that, whatever. Like 10 to the 8, you're on the scale of planets. And then, I don't know, it seems to end at 10 to the 35, I think, is the number of particles in the universe, something like that. It's the scale, it's the largest scale of the universe, because that's where everything breaks down. Nothing can go faster than the speed of light. So we have no information about anything outside of that region. Just we're limited by the laws of physics, but it goes up to 10 to 35. And if you go down, we get to like the Planck distance, where the laws of physics break down at 10 to the negative 35. So 1 over 10 to the 35.
Wow.
Give or take. But it feels like we're right in the middle. And we know that like if we were bugs, then water to us would be as thick. Water to us would be like getting stuck in a pool of honey or something. Because at that scale, everything just takes on a different meaning.
Yeah.
So it just feels kind of weird, but according to the reason why these things are not infinitely divisible is because our understanding, our models, our theories don't allow these things to be divided. It just doesn't seem that our current models can get smaller. So maybe there are, but it would also be a really weird universe where time and existence has like a completely different meaning, because at that scale of quantum materials, subatomic particles, things pop in and out of existence. Things exist as probability waves. They could be anywhere in the universe. So these things aren't intuitive to us and would look nothing, if you're at that scale, it would look nothing like what you're used to. And yeah, it wouldn't even make any sense, because you can't shrink a human down to that scale, because they would die as soon as you took out all the vacuum space between their atoms. They would most definitely die. Like these atoms would just not work.
Yeah, that makes sense.
But yeah. So the reason we brought this up, Socrates, Plato, they talked about everything has to be cross-examined. You have to be logically, analyzing everything someone says, and you talk about it back and forth. Right. That's how you arrive at the truth. And the sophists were rhetoricians. So that meant they would argue for their point. They would say, this is what we should be doing. And then it was a matter of persuading your audience to accept your point and say, that makes sense to me. We should go with them. And then they would like debate it out. So it's different than the dialectic, because that is more breaking down everything the other person says, making sure it's logically consistent. Rhetoricians, they don't necessarily care about the logical consistency. It's all about appealing to the other side and how good you are at that.
Oh.
And so the truth is subject to who can argue better, who can. It ultimately comes down to what the audience wants to believe and who they want to believe.
Interesting. I'm losing respect for the sophists now.
Well, the whole point of me bringing this up was to kind of bring back the respect for the sophists, because that's what the guy argues for in the book.
Okay. So maybe we're not giving them the most credit we could, because maybe there's something deeper going on in the worldview of the sophists. Yeah.
The thing was that they would argue about what the good is, what's best. But the dialectics would just say, we don't know what's best. And whatever it is, we have to logically analyze it. You can't just believe it. You can't arrive there through like your own personal will. It's got to be like built from the ground up logically. Anything else we would throw out. So I'll read an excerpt from the book. Plato's hatred of the rhetoricians was part of a much larger struggle in which the reality of the good, capital G, represented by the sophists, and the reality of the true, represented by the dialecticians, were engaged in a huge struggle for the future mind of man. Truth won, the good lost, and that is why today we have so little difficulty accepting the reality of truth and so much difficulty accepting the reality of quality, even though there's no more agreement in one area than the other. So, yeah.
I'm a little confused by that last sentence because he seems to say that truth won, the good lost. And what does he mean by that? It means that people gravitated towards the side of the dialecticians, the truth, rather than the side of the sophists. But then he ends with saying, even though there's no more agreement in one area than in the other. Sounds like there's more agreement for the side of truth. That's why they won.
Well, according to him, they only convinced us that they won. What? No, they only convinced us that truth is more reliable, and that's something you could actually agree. That something that you could actually come to objectively. He's trying to say that the truth ultimately is subjective. Even in science, there's ultimately a subjectivity of how you arrived, what things we want to analyze. Even if something is true, it's through our eyes, subjective. But what's good is, yeah, he agrees that's not something that people agree with or can come to some consensus on. But that is just as important.
Okay. I'm still a little confused by the last sentence, but I understand and accept your explanation.
I will preface that there are people that have read the book and said, this doesn't make sense. It's not rigorous. So, it's not necessarily logical. It doesn't define everything. But you could see how we spend so much time. Like the influence on us is very clear. We define everything. We're going through this dialectician. I mean, we do both. But a lot of it is analyzing, picking apart everything. We argue for what's good and what makes something good. But we're like, oh, that's just our own opinion, so it's fine. But we sometimes push past this idea that even when we're saying something is true, something scientifically true, it still is heavily influenced and biased by us as well.
In theory, I accept. I would need to understand the example of when we're biased while being scientific. I'm not rejecting the possibility.
Right. Well, it's just, the point is, whatever you say, ultimately is coming through whatever. Yeah, I think you sort of get.
Maybe that's the topic for another episode.
Okay. Yeah. In the next paragraph.
Whether objectivity is ever possible.
Right.
But anyway, sorry, continue.
So it kind of gets into in the next paragraph. Man is the measure of all things. Yes, that is what he is saying about quality. Man is not the source of all things, as the subjective idealists would say, nor is he the passive observer of all things, as the objective idealists and materialists would say. So he's saying what makes something good is dependent on man. Now, what's good, it's not just something that's subjective, that you think, oh, this is good, that's good. There is a good that exists. There is something that's better, that we can't just say what you think is good is your own opinion, what I think is good is my own opinion. It exists out there. Because that limits it. If we say that it's just subjective, and your opinion, it brings down the value of it. But it's still not objective. It's not for sure set in concrete that we could pick it apart and analyze it empirically. We can't do that. So it exists in the middle, and the only way we reach it is through our experience, through man. The quality which creates the world emerges as a relationship between man and his experience. He is a participant in the creation of all things. So his point, I think, was not that just like that the dialecticians were wrong, it's that they attacked the sophists too much. They said, you just talk about subjective good things, opinions, worthless. Doesn't mean anything if it's not scientific. And then we kind of gave up on that as humanity, as a culture, as a society. We said, science, that's holy. Whatever science says, that's the truth. We accept that. And we leave whatever one person prefers over another. Everyone does whatever they want. That's a different domain. And we've abandoned that. We don't respect that. We don't respect people who try to argue for what's the good to do. And so he laments that humanity has lost this aspect. And that science is, this method ultimately that doesn't address the good. We associate it almost religiously with a holiness and a respect and a reverence that we even go so far as to say it's good. It just talks about the truth. It doesn't address what's good. What is good is it's a different field that we have to pursue as well. And that was kind of what I was driving to with what science isn't. And we could talk more about how Neil deGrasse Tyson and Bill Nye and Carl Sagan were all pushing for this science is good. It's ultimately it's beautiful. It fills you with meaning and joy. But that's just their own subjective interpretation of what they think is good. Maybe they're right, but it's not what science does. And I'll tell you my personal experience with science and what it's revealed to me and everyone is that on our scale, we're completely insignificant. What science has revealed to everyone is that we exist for a nanosecond within the universe. The universe is 13 billion years old, and we exist for 80 years on average. And then in terms of space, we're infinitesimal compared, we exist on a planet. The planet is massive compared to us. We have no effect on it, basically. We exist in a solar system, multiple planets, and then for each star, there's 1 billion stars in the galaxy. And then there's billions of galaxies, so billions and billions, and these are so far apart.
For each star, there are 1 billion stars?
No, for each galaxy, there's 1 billion stars.
Okay.
Sorry. And these
galaxies have an infinite recursion of stars there.
Well, there are at the center of most galaxies a black hole or something, which is a collapsed star. But these galaxies are so far apart, you'll never be able to reach them. Humans, according to science, are just made up of matter, atoms. There's no soul. There's no.
You just did one of the mistakes that we talked about in the beginning of this episode. You said humans, according to science, are just matter.
Yes.
Are just
atoms.
Atoms. There's no soul. Science doesn't say that at all. Science does not make a claim about what a human is or isn't or is only.
Sure it is.
Science makes a claim about what science is able to make a claim about what is in the human. But you can't say my hypothesis is there's no soul in the human. First of all, unfalsifiable. Second of all, I guess that's really the only point. It's unfalsifiable.
So we should
you won't be able to set up a test and show me that there's no soul in the human. You can set up a test and show that there's something else. You can observe the heart and the lungs, but science doesn't make a claim that it encompasses everything.
So I think we
science
should
is inherently
clarify that if a theory is unfalsifiable, then it is rejected by science.
It is not rejected by science. It is rejected practically, in meaning that as a truth statement, it is not rejected. Rather, as a statement to be examined and tested, it is rejected, but not as a truth statement.
Okay, as a truth statement, it's not. But as far as science and scientists are concerned, it is rejected as a theory. That's how it works. If you come up with a theory that there's a teapot orbiting Saturn, but you're never going to be able to
very
figure it
falsifiable.
out.
I've heard that example thrown out. Very falsifiable. We know that there's no teapot orbiting Saturn.
How do we know?
We have ways of knowing. We have ways
intrinsic
of seeing
in the point is
Saturn.
That you can't really observe on that scale of. We have spacecraft orbiting Saturn, but they wouldn't be able to. The scale of Saturn is so massive.
Wait, we have spacecraft orbiting Saturn?
I know we have one orbiting Jupiter, Juno. I think.
I'm
pretty sure we still have.
No humans inside, obviously.
No.
Okay.
Humans have not gone
to
further
Mars.
than the moon.
Right.
And we only have humans orbiting the Earth right now.
Okay. Yeah.
For the past 50 years.
But my point, so it's a mistake. It's a category error. It's a conflation of bad language to say, according to science, a human is just matter and atoms, and there's no soul. Science explores the physical parts of a human. It doesn't make any truth claim about that. That's all there is.
But I think intrinsically in the method, it requires that your hypothesis be unfalsifiable. And if it's not, then it's not scientific.
It's not scientific. That doesn't mean it's not true.
It doesn't mean it's not true, but according to science, it ought to be thrown out.
It ought to be rejected practically as a scientific pursuit. We're not going to pursue this scientifically. You can explore it in other ways, but for the purposes of
science and scientists and following the scientific method would say, throw it out.
Well, throw it out of this particular domain.
Of science.
Yes. Yeah, but I thought this whole podcast was about how science isn't everything, and it's a tool, and there are things that science is not,
right.
And those things don't cease to exist because they are not science.
Right, but I'm talking about according to science.
Okay.
that should be rejected. I'm talking about.
But science doesn't.
I'm not saying true or not. I'm saying science. Yeah, exactly. Science doesn't make claims about what's good, but it does make claims about what is scientific and what is not scientific.
Okay.
So according to science, humans are just made of atoms and are carbon-based life forms.
I would phrase that differently, but very well. Go ahead.
Okay. So that's the point. The point is that science, in my opinion, paints a very bleak picture of reality. Before science...
See, but there you go. You're using that as a truth claim now. You're saying science paints...
No, I said it in my opinion.
Well, you said, in your opinion, science paints a bleak picture of reality.
Yes.
Because in your opinion, science is making a truth claim about the lack of a soul in a human being.
No, it's my interpretation of the scientific facts that it's very bleak. And that...
Okay. All right. Fine.
And my point is that Neil deGrasse Tyson looks at science, and for him, it paints a very... positive picture of reality.
Right.
And that religion paints a very dark and ignorant picture of reality.
Yeah.
And my point is just that it matters the person. It matters. You can't just say science will make all of us happy. It won't necessarily.
Yeah.
You can't just say equally that religion will make us all happy. It depends on the person. It depends how they feel. And yeah, that was my point.
Okay. I wanted to go back and address when you said that. I'm paraphrasing now. I'm sorry if I'm putting words in your mouth, but it sounded like you were saying that according to science, we are a blink of an eye or a nanosecond in relative to the history of the age of the universe, and also that relative to the size of the universe, we are a speck of dust. You can't escape the human bias here, though. Meaning it's an attempt to kind of come out of the human bias and say, okay, well, we have a human bias of immediacy and that we are the center of things. So, we kind of think we're important, and then, but look at that, we're a nanosecond in the age of the universe, or we are super small in comparison to the size of the universe. But we're still using human biases here because where do we even get that length of time is significant, that more time is more significant than less time, or that greater distance is more significant than less distance, or that distance and time have any relation to what is significant or what is real or what is valuable? Real, of course. Sorry, I shouldn't have said real there. Being obviously it's real, but what is significant, I should say. What contains more meaning? What the hierarchies of value here that we're creating are themselves. They come, meaning you are yourself using a value hierarchy there, where you suggest that greater distance implies greater significance. We are small distance, so we are less significant. But that itself is a human-made hierarchy.
I agree.
Okay.
But the point, okay, so yes, when it comes to statistics, what makes something significant is, I think they say it's a p-value of 0.2 or something, which is 98% of the, greater than 98% of the normal distribution is insignificant. Anything that resides within the 98% is significant or something that's not just an outlier. Maybe I got my specifics wrong.
Okay, something like that.
Yes, this is just ultimately humans have decided this seems like a good place to put it because of what I think is reasonable, rational decision making.
Wait, this seems like a good place to put what?
The definition of significance.
Oh, we're talking about the P level now?
Yeah, but it could be extended as well to distances in the universe, sizes in the universe. Not just this p-value, but the fact that there's a consensus in general of what is significant. And I think that you would be irrational if you consider yourself significant to a galaxy, to the size of a galaxy, when in every other aspect of your life, you ascribe no significance to tiny atoms on the floor, but you do for a table or a chair, which has the same scale as you.
No. I ascribe much more significance to that book, which is small as compared to the wall, which is big, or a diamond, which is small, versus a blanket.
Okay, I'm not saying that there's a pure correlation.
Okay.
I'm saying there's a high correlation.
You're saying, first of all, once there's not a pure correlation, okay, so who cares? Because
that's the whole point of correlation. There doesn't have to be a 1-to-1 correlation for something to be significant.
Well, no, because we're talking about a real value hierarchy here that is meant to have real grounding in reality, to say that size implies more significance. Just because
it's correlated.
It's correlated. But if it's not perfectly correlated, then that shows that there's something wrong with the value hierarchy. The correlation now becomes happenstance. It happens to be that that bigger things are often more significant, but it might just be a correlation and not a causation. They're caused by the significance is caused by a third factor.
Okay, it is more complex than just size, but my point is that you don't ascribe any significance to things that existed way before you, mostly. Like out of 99.999% of the universe that existed before you, you don't care about. And out of 99.999% of the universe that exists after you, you also don't care about.
So what's the point?
The point, okay, you have your own, obviously we all have our personal significance. We do think that, I care a lot about my homework because it's going to have a large impact on my life if I don't do it. But if we take a step back and we leave this personal bias, we can just look at the facts that science has presented us through following its method that scientists have shown and proposed this model of the universe. That our lives are over in the blink of an eye. We're just atoms. There's no real difference when you just break apart atoms in one spot. So there's no real difference when you break apart atoms in another spot, if it's a human versus a piece of wood.
Observable difference.
Observable difference. Now, obviously, we wouldn't have a functional society, and we wouldn't feel good because of how we've evolved.
I granted way too much there. There's so much observable difference when you murder a human being versus when you break apart a piece of wood.
Because of society, from a universal perspective, there's not. From your own personal biased societal human existence, there is.
So, but my point is that you're trying to go into this universal perspective, but you can't. You don't get to claim universal perspective here, because every attempt to go into this universal perspective itself is burdened by human constructs. So I started by saying the very claim that there is significance to physical size is itself a human construct. And so the very claim that, big universe, more significant, small human, less significant, that is not a universal point of view, that is a human point of view. But then again, when you try to go into this universal perspective and say, the human being is just like the piece of wood, and the two of them can be dissolved and disintegrated, and I totally reject that this is a universal perspective. I reject that we have now gone into this kind of, we're seeing things objectively, where we've decided to ignore lots of things that we see and feel and say, okay, let's look at it through this lens. And from this lens, there's no difference. But there's no reason to say that is the lens of reality, that is the lens of universality.
Okay. So let's assume, for a second, we're assuming scientific universe, okay?
Okay.
Everything that science says is true. Anything that's unfalsifiable, like God, heaven, soul, are not, okay?
Okay.
Why do something good and significant in your life? Give me an example of something significant in your life.
There were two things there. Why do something, and give me an example.
Okay. There is momentary pleasure. I'm not going to deny that, but fine. Give me an example of doing something good for someone, okay?
Give an example of doing something.
Sorry, that is the example. You do a good deed, okay? Why do you do a good deed?
You're asking me?
Yeah.
Why do I do a good deed? And we're assuming a scientific, a physicalist worldview.
Yeah.
Okay. Why do a good deed? It's very hard for me to assume a physicalist worldview. Because I don't really believe that.
Where are you going to say just because it gets me points in heaven, it uplifts my soul?
No, I wasn't going to say that. You're saying I would say that if I wasn't adopting a physicalist worldview? Is that your question?
Well, if you were struggling with it, like you say you are, so then that's what I assume you're thinking.
No.
So why are you struggling?
Because there are ways I wish to talk about reality and the life that we live, but I can't if we're assuming a physicalist worldview, because all of that language assumes. I don't even know that it assumes. It just naturally hints to something greater than merely what is physical. It doesn't even say it's not about like, oh, it's a calculus. It's a selfish calculus of, oh, I will get to heaven and I will get reward. It's not about that at all. It's about noticing and acknowledging the divine and the deep and the beautiful. And all these things don't really exist in a physicalist worldview. All these things are kind of just like, well, we just kind of have that sense that there's beauty there, but beauty isn't a real thing.
So are you agreeing with me that if you don't have divinity and soul and God, then there isn't much point in the universe if it's purely from a realistic point of view, and there's not much point in doing good, let's say?
Okay. A number of things going on here. Not much point to the universe, not much point in doing good.
In doing good, that's it.
Okay. Well, I do think that the fundamental axiom that drives anybody who gets up in the morning and lives a healthy, productive, and good life, that fundamental, whatever set of axioms, single axiom, whatever you want to say, the things that are at the fundamental base of that person are not scientific. They are metaphysical. That person believes something metaphysical about the world, whether he says it or not. Anyone who is living a productive, happy life where they get up in the morning and they're doing something good, especially if they're doing something kind for other people, at the base of that person's heart, there is a belief that is metaphysical about the world, not reduced to physicalism at all.
Okay. So now, with that disclaimer out of the way, let's just play the game and humor me.
Okay, yeah, I'm happy to play the game, please.
Why help an old lady cross the road?
Assuming a physicalist worldview.
Yes. You can do it.
It makes me feel good?
Okay, good.
Okay.
It makes you feel good. It makes her feel good.
Whoa, it makes her feel good. What do I care about that?
Okay. It makes you feel good.
Okay.
It increases your dopamine.
Okay. Increases my dopamine.
Okay.
All right.
Now, your dopamine, short-lived. This act of kindness, it's over in an instant. This woman will die.
Mm-hmm.
No memory of this act of kindness will survive.
Assuming a physicalist worldview.
Assuming a physical worldview. In another, okay, even just like another, year. Probably no one will even like remember it a few days later.
Okay.
Whatever. Let's say you say, that's not good enough. I want to donate all my money. I'm going to, get everyone in Africa. I'm going to build all these houses, get them all their shots and stuff. People remember that for 1,000 years.
Okay. I hear you.
Still finite.
True.
Let's say you revolutionize the world. You stop war.
Wow.
You figure everything out. You figure out death. Death is no longer a thing. Assuming a physicalist worldview, then that is a good thing.
In the Matrix, in the movie The Matrix, Morpheus says there's a difference between knowing the path and walking the path. So if we were to do all of that, I think we would be the Messiah, but we would be in a physicalist worldview, so we wouldn't believe that is there such a thing as a Messiah? But we would be the Messiah. We would be walking the path without knowing the path. Sorry,
okay.
Continue.
Sure. Yeah, I'm fine with calling that the Messiah. I don't care that it has like a religious connotation.
Okay.
The savior of mankind.
Okay, yeah.
It's synonymous.
Yeah, exactly.
So you do all of that. For generations, everyone remembers you.
Mm-hmm.
They praise your name.
Mm-hmm.
In 1 billion years, the Earth will cease to exist. It will be, according to science, the sun.
That's not falsifiable. You can't falsify the claim that the universe will cease to exist.
Okay, so we got to talk a bit more about what science tells us about its theories. It does. We extrapolate theories.
Extrapolation is fair if done correctly.
Yes. We assume a universality of nature. The principles by which they arrive at the conclusion that the sun will expand until it destroys everything, including the Earth in the solar system, are based on physical principles, on physical models that we have observed at a much smaller scale that are falsifiable.
Very well, but
and
this is assuming
from the universality of nature that we've extrapolated that the atoms that we have here are the same as on the sun, because when we look through spectroscopy, which is looking at the light provided from atoms, we could determine which type of atoms they are, which element they comprise.
Oh, interesting.
Yeah, so that's how we could look anywhere in the universe. We assume, the spectroscopic signal or signature of the light is giving us whatever on Earth when we look at that element, it matches.
But I think there's another assumption that you haven't mentioned, which is the assumption of no added externalities. The assumption that our model can be applied accurately to this situation that we're talking about. Which, of course, you have to go with, because you can't assume externalities. But from a more scientifically, you have to go with that. But realistically, there could certainly be externalities that make the model inaccurate.
You're saying there could be someone, we come together as a species, we somehow develop things on the scale of a Dyson sphere to contain the sun, which is...
Sure.
But by all scientific models right now, a Dyson sphere is impossible to construct because we have no material that is strong enough.
Okay, but you also...
Maybe it's possible. In science fiction, it is theorized.
Okay, but
but there's no rationale for believing in such a thing.
Hold on.
And even if the sun doesn't take us, a black hole will. Even if we escape all of that, the heat death of the universe, where entropy, which is scientifically shown to always be increasing until there's no energy left in the universe. Everything is just uniform, meaning life cannot exist as we know it. In however many billions of years that happens, it's inevitable.
Let's accept that.
And every memory of every good deed, everything that you did is wiped out forever. Not a trace of it is left. Physically impossible, according to science, that any part of you, anything you do, no matter what, remains.
Okay, let's say.
So let's say. That's not to mean that you should just kill yourself now, because nothing means anything.
Okay.
Obviously, you have certain selfish interest in your immediate timeline to make things better for yourself and benefit yourself. And benefiting everyone around you usually helps with that. Through evolutionary forces as well. You don't want to do that. But in terms of truth, in terms of anything having any meaning, ultimately, anything we do is wiped out. And therefore, there cannot exist any meaningful actions that you could do in the universe. Anything of significance, ultimately.
This is such a conflation of... Science doesn't say this. A particular interpretation of science says this. A particular way of kind of moving from science to, using certain human biases. And there's so much of the human mind that just went into what you just said. And science, first of all, we established that science doesn't say anything about morality. It doesn't say anything about meaning either. It doesn't actually say anything about significance. It's very just, these are the facts.
I agree still, that this is my interpretation. And Neil deGrasse Tyson or Vsauce, a YouTube educator, will say, his latest video was on the meaning in the world of, like, there's your immediate death of your physical self, and then there's your name death, which is the last time anyone on Earth mentions your name.
Oh, yeah.
And then there's still the butterfly effect, which is, even your existence, just that has some effect on the atoms around you that affects other things and sends out this, wavelength, even if it's so tiny and unobservable, it's still there within the universe, and it will be till the end of the universe. Sure, that's
You can say, though,
different interpretation.
Yeah, but you could also say, well, what does that even matter? Like, why do I care that my wavelength is going to go out?
Which is what I say, because I don't think we care about, that's my refutation to that. I don't think we care about unobservable, tiny, useless waves, pointless waves in the universe. What we care about is doing something, if we want to be consistent and rational. The reason you do anything is because you want people to see it. You want yourself to notice it. If you yourself can't even notice it, we don't do it. There's no point. So why not extend that to, if no one will ever, ultimately, it'll just disappear, why do it?
Well, deducing that something exists is a kind of noticing it. So you can't say that, well, don't deduce it because you wouldn't do it if you didn't notice it, but I'm deducing it. I'm noticing it. Meaning, you get what I'm saying? Like, even if you don't see something yourself, inferring that it exists through seeing through your mind is a form of seeing it.
Right. But that's my point, that we don't care about these things that we can't even deduce or see. Why not kill someone from a purely...
Assuming a physicalist worldview. There's a lot of reasons. The obvious first reason...
Disclaimer, don't kill people. Yes.
Yeah, no. The obvious first reason is because if I did so, I myself would be arrested, imprisoned for life, possibly put to death. I myself...
Let's assume you don't suffer in a certain way.
Let's assume I get away with it.
Yeah.
So here I can say, even assuming a physicalist worldview, I'm not assuming a soul here, but your psyche will torture you for the rest of your life if you murder somebody.
Okay, let's say you get away with it, and they'll only discover it in 100 years. Let's say you're a psychopath, and that kind of defeats the whole purpose. Let's say you could steal $1 million. They'll only discover it after you're dead.
You can steal $1 million. They'll only discover it after I'm dead. And there's no orphan who needs that money and has the.
Let's say there is.
Well, who am I stealing it from? Am I stealing it from some
Yeah, you're stealing it from someone.
Okay.
So you're screwing over some orphan.
Okay.
Your name will be tarnished in 100 years.
In 100 years. Why not do it?
Given that everyone's going to die anyways.
And
no one will remember, even if your name is tarnished now, though the rest of the world will cease to exist. No one will be there to remember.
Can you remind me?
You did.
Can you remind me what we're getting at right now? Why are we going down this path?
The point was just that, in my opinion, science paints a bleak picture of the universe, one that requires a rethinking of our moral structure and understanding of why we do things, why we are good people, and assuming what do we call it?
A physicalist worldview.
Physicalist worldview, that if this is now our way of looking at the world, because things like the soul and are thrown in the lot of unfalsifiable and therefore unreasonable, we have to come up with some replacement to argue about why people should still find meaning in their life. And it could be that science, just kind of screws us over and we won't be able to find a satisfactory replacement, and that maybe we were happier with religion, theoretically at least, minus all of the religious wars and inquisitions.
People are going to fight about things they're passionate about.
Mm-hmm. Okay.
But anyway, that's a separate topic. Wait, so I'm fine with that because, right, if we're saying that science paints a bleak picture of the universe, which on many levels I agree. I mean, I do think that in many ways the universe is very bleak and life is quite bleak at times. If we're saying that as to kind of disagree with Neil deGrasse Tyson and whoever who's suggesting that we will find everything we need in science, right? Everyone just embrace science and we'll all just be super happy. It's so exciting, science.
We'll find the beauty. We'll be happy because we'll learn more and push away the ignorance.
Yeah.
The field of ignorance that we had before.
Yeah.
That previously everything had to be explained by religion, and the amount of explainable things has expanded, and the amount of things that we need religion and the paranormal and unfalsifiable theories to explain has been reduced, and it's all about pushing that further back. But yeah, he's saying this is a source of joy and stuff, and I reject that it's so obvious.
Yeah, I agree with that.
Okay.
Yeah, if that's the whole point of this. Yeah, I'm with you.
Yeah. Okay.
Yeah.
But I still think everything is pointless.
Also, I don't believe in a physicalist worldview, just for the record. So I was playing the game there.
Mm-hmm.
Yeah.
Do you believe in a teapot orbiting Saturn?
No. And it's not a comparable belief to a belief in God. First of all, a teapot orbiting Saturn is falsifiable, and we know it's not true.
Fine. Okay, a teapot orbiting
some other planet in some other galaxy.
And I will agree it's not on the same scale as God, because I think God is a very vague, abstract term that could be applied to, maybe some Buddhist version of just like the universe itself, and obviously I'd believe in the universe itself and the interactions within.
Yeah, I think that's a bit of a cop-out though.
Yeah. So when I'm talking about conflating it with something, I'm talking about like heaven according to a specific religion, or a soul, or God according to his version according to a specific religion. So like the anthropomorphic God, that he's like that he looks like a man, or has mannerisms of a man, or something. I'm conflating it not with the abstract idea of God. I'm saying if you don't believe in a teapot orbiting some distant rock, why do you believe in angels, let's say?
So there's a lot of reason to reject an idea that there's a teapot orbiting some distant planet in a very far off galaxy that is too far from our universe that we've never even observed. And it's quite logically it's very likely that doesn't exist, because teapots were invented on Earth. So we, like, teapots are something that we have here, that we invented here. The odds that there's actually a teapot in some other galaxy, it would have to be not invented by humans, right? It would have to be some naturally occurring teapot. We've never observed a naturally occurring teapot.
Aren't angels and that vision of an angel of a human with wings, or not a human, but like some sort of anthropomorphic being with wings, that's something invented according to our vision on Earth, and we're projecting it into the heavens. So, our idea of heaven of being in ecstasy and joy is something that exists only on Earth, as far as we know.
What was the point about joy? Sorry, I lost that.
Joy it's just a feeling that only exists on Earth. So why do we project it to be in heaven? That we're just going to be in ecstasy in heaven. Maybe it'll be hell. Maybe it'll be something that we just don't understand at all.
Okay, so first of all, joy is much older than teapots, right? Teapots, we know that there was a time when teapots didn't exist, and then they were invented, and they've been around for since then. So the idea that there would be a teapot not invented by humans, naturally occurring, orbiting around some other distant planet. Quite implausible. Joy,
but not impossible.
well, I can't say for sure it's impossible.
But
it's
would you
logically,
personally
theoretically possible.
believe in it if I told you a specific planetoid where you're saying no, you wouldn't believe in it?
I certainly don't believe it right now. If you were to tell me, I do trust you. And if you were to say that the research is...
No. I'm saying I'm not saying that it is out there. I'm saying, okay, you're saying if the research says...
I mean, if you said the research is good and like current science suggests there's a teapot orbiting some really far off planet in some other galaxy, I'd be like, all right, well, now my belief in it has certainly risen from 0 to some number.
Okay. Well, all right. I mean, I don't know how to feel about that because on the one hand, it's very, flattering that you would trust me like that. On the other hand, I'm worried about your critical thinking.
What, you don't think that that's possible? If the
you just said it's ridiculous because
it's certainly ridiculous when
they're invented on Earth.
It's certainly ridiculous when you offer it as just a claim, like, oh, sort of trying to compare it to a belief in God, like, oh, why don't you believe in a teapot orbiting some galaxy? Well, it's obviously ridiculous. It's a ridiculous claim,
right? And it would the easier explanation, which is another aspect of science that it prefers to. Which we haven't gotten to, I guess, some of the principles, but we're discussing that. That it's not the simpler explanation is that I'm just messing with you about the teapot.
Well, that's why I said it would rise from 0 to some number. Right. I didn't say it would rise from 0 to 100. And when I say I trust you, I also believe I have some ability to know when you're messing with me. So it would have to be that you claimed it to me, and also I was convinced that you were not messing with me. Both of those things I assumed.
Okay.
But like the contingency argument that all things were caused by something else, and therefore if you go from one thing that was caused to another thing that was caused to another thing, there must be something that caused the first thing. That doesn't apply to a teapot orbiting some planet. That applies to God. There are rational arguments for God. There are rational ways of viewing the world that lead one to a belief in God. There aren't rational ways of viewing the world that lead one to a belief in a teapot orbiting some far-off planet.
Okay, so again, when it comes to God, I think that it depends on your definition of God. If you just think that it's the first force that happened, then you can equate it with the Big Bang. But do you believe in angels?
I don't know. I don't think that that's something that has that much significance on my life. Angels, if I do believe in angels, I believe they do God's bidding anyway. So, like, it's the belief in God that's far more important. Meaning, the angels strike me as more of an implementation detail. It's like the interface is God, and the implementation detail is the angels. I don't care about the implementation detail.
So, yes or no? Because I know you don't care. I hear that. So no?
My only reason to believe in angels is because they are described in the Bible. Like, they're certainly, at least, it certainly sounds from the way the Bible writes many times that there are angels. And I'm trying to separate from the culture that I'm a part of. Rationally speaking, I do believe there is reason to think that the Bible is telling us something about the nature of God, and that whether we can say, so maybe it was, the at least the first part of it was directly told from God to Moses, maybe, or it was compiled by human beings over time, but there was kind of a divine inspiration that caused that to happen. So, like, even if we say that it was compiled naturally, I think there's reason to believe that there was a divine force behind it. So anyway, the Bible says there are angels, but again, it doesn't really matter because it could just be using that as
a metaphor.
It could just be, it doesn't really matter whether there are angels.
Okay, souls.
So souls, I definitely believe in, yeah.
Okay.
The soul,
and they're significant enough for you to care.
Oh, absolutely. The soul I equate with my sanctity as a human. It's what makes me not just a bunch of atoms.
Okay.
It's what makes me something more valuable.
Is it an idea like similar to God? Is it something that you just, it's a way of expressing the same thing, just the same thing that I would believe in, the sanctity of a person from like a human rights point of view? Or is it something that
no? It's a statement about reality. It's a statement that the human being is not just a bunch of atoms. That you could essentially make a human being in a lab, if let's say you could, and you would fail to because you'd be missing a component.
Okay, so why do you believe in that and not a teapot orbiting?
Because there's a lot of evidence for it.
But by definition, there's no evidence.
Actually, I disagree. I think our consciousness is very strong evidence for a soul. I think our consciousness is not explained scientifically. It's not explained by any other explanation. And qualitatively, it certainly seems to be something different from every other aspect of us that is examined by science. So our own consciousness is evidence of a soul.
Okay, so I want to say one of the questions we also want to address is, can science ultimately explain everything?
Mm-hmm.
Every phenomenon that exists in reality, at least. So whether that's multiverses or consciousness, because I think scientists can agree that consciousness exists. There is some sort of pattern in the human mind that is highly complex, that makes us self-aware. The problem is we can't really define it, so how do we know it exists if we can't define it? We know something's there, and part of the scientific exploration would involve coming up with a better definition.
So in this podcast episode, we were talking about the limits of science, but you just said, how do we know if it exists if you can't define it? I would say we should abolish this assumption that only things that can be defined exist. That's making science too expansive. That's saying only things that can be put into the domain of science exist. There are things that exist that cannot be defined. Sure.
Things that, okay, for example?
Consciousness.
Okay.
Consciousness is the most obvious one. Anything else? Consciousness is, like, I am more...
But I don't even know, like, if I don't know what it is, how do I know it exists?
The question to me doesn't make any sense. I'm the most confident that consciousness exists. It's the first step.
But what is it?
We did this on another episode.
Yeah. So we don't want to get back into this.
I kind of do, but we don't have to. We won't. We shouldn't. I want to, but we shouldn't.
Okay. So I do want to talk, maybe shift it a little bit to talking a bit more about science in terms of what it is.
Okay.
And one part of it that we said, it's it's made of established facts, theories, models, and laws. We've used those words a lot. So what are they? Scientific laws describe a regular pattern in nature, but they don't explain why it happens. So, for example, the first law of thermodynamics, that energy cannot be created or destroyed, only converted from one form to another. This is something that we've observed. We take in a closed system where, we're burning fuel or something. We want to let's say we burn fuel to create hot water. And then we want to use that hot water to, to perpetuate the cycle of energy. We want to use the hot water to do something that will burn the fuel again.
Okay.
I don't know. We want to power our engine that we burn fuel with to recreate the fuel. Terrible example. I don't know why I can't think of any examples now.
What are you trying to describe conceptually?
A perpetual motion machine where, let's say I want to drop a marble, okay? on a track and have it fly back up. Like we know it'll gain a lot of momentum by going down the track. At the end, it has a loop. We want it to come back on the loop, go back to the top, and just keep flying forever. This never works. From experience, we see that it always comes to rest. There's always, if we want it to continue to go up and down this track, we must introduce external energy into the system.
Mm-hmm.
So that's a law. That's something we see. We don't have like a good explanation necessarily of why it is, but that's the law. We have Newton's laws of motions. So that things fall, that bodies of mass, bodies with mass attract each other. We see that, you drop something, it'll fall. We don't know why. It doesn't explain why. It just means things are going to fall at a certain rate. We have Galileo, yeah.
Included in Newton's law of universal gravity, I forget what it's called
Gravitation,
exactly.
yeah.
Universal gravitation. Included in that is a gravitational constant.
Yes.
And a formula.
Yeah.
That can be used to determine acceleration. They can be used to determine the acceleration that an object will have due to the gravitational pull of another object. Am I correct in that?
Yes, exactly. So what Galileo did, he came before Newton. What everyone thought before, and what Aristotle said, was that everything falls at a constant rate towards the ground. You drop a ball, it falls at, let's say, 10 meters per second. It doesn't matter whether you drop it from the Eiffel Tower or from 5 feet, it'll always fall the same speed.
Meaning there's no acceleration?
Yeah, that's what they believed.
That seems weird, that they didn't realize it got faster as it fell further.
It seems weird. And I think it's in line with the fact that I don't think science is intuitive, like you said. And that people would just look and take their experiences as fact. They would their daily experience. They'd say, because the change really is imperceptible. You look at a falling object, you can't really tell that it's going that much faster or that it's sped up.
Hold on. There's no way they believe this. Because if you jump off a stool and hit the ground, you won't die. If you jump off a building and hit the ground, their buildings weren't that tall in those days, so you'll break a leg. So how do they not understand that you get faster as you fall further?
It's a good point.
If you drop a bowl from your ground floor window, it won't shatter, assuming it's not that hard of a ground. If you drop a bowl from your second floor window, it'll shatter.
Well, there is air resistance.
Okay.
So, not like if you drop a feather from a tall tower, it's not going to explode and go into the ground at So yeah, they didn't really experiment by throwing people off all the time, but you're right that built into that assumption that when you throw someone off a bridge, they'll die, or off of the battle, the rampart of a castle or whatever, they'll die. Whereas if you push them over, they won't. Like if you push them over onto the ground from standing height.
Yeah.
These are good questions, but my point about the feathers, that like it was kind of weird because you drop a feather and then it doesn't fall that fast. So clearly they understood something else is like going on here. They didn't. I don't know. If you look it up, that's what Aristotle believed.
Okay.
But please double check.
Sometimes people spend too much time in their library. Too much time reading. You got to go out and experience the world.
And do the science. Yeah, experience.
Yeah, or just.
Although I will say that Einstein made a lot of his discoveries just by thought experiments and by imagining what it's like for a person to fall where they're falling from such a large height that they don't actually feel that there's a difference between that and just being in free fall without any gravity. Like there's no difference between free fall and just being in the middle of space without any gravity.
Okay.
And they would experience it the same, but this was just all in his head. He wasn't actually skydiving.
Mm-hmm.
But he still reached very interesting conclusions and true conclusions based off of these thought experiments. So, sorry. So yeah, that's what they believed. But then Galileo came along and said, okay, I'm going to do an experiment and I'm going to measure this, because it was very hard to actually measure what the rate of acceleration is, meaning that the speed increases over time. So you're falling 3 feet per second. This is going to increase to 9 feet per second and go faster a few seconds later.
Mm-hmm.
So he took a ramp and notches, and he would like drop a marble or water or something, and saw how fast on this slope it traveled. And so he slowed it down, but he found that it doesn't matter the angle of the ramp. It was always accelerating at a constant speed, and because it was slower, he was able to measure it by how fast it passed the notches in the ramp.
Okay.
And he got to the number 9.81 meters per second squared. So that's a law because they found this number, and they said that's just I don't know what that is. But and I think Newton came up with a better, more of a theory. So a theory explains why things are true, but I think we still called it a law because it didn't explain enough. But he was able to show how you could get to the number 9.81 based off of the bodies of mass that you're using. So if you're using the Earth and know the mass of the Earth, and then you could calculate the acceleration that it will have on every object, more or less. Every object of normal scale. I think that means that if you have a smaller object, the gravitational pull will be a tiny bit different, but it's so insignificant that it's basically 9.81 for everything. Because the mass of the Earth is so
much bigger,
so much larger. So another example of a law is Zipf's law, ZIPFS, and what that means is that by observation they found that the frequency of an item is inversely proportional to its rank. This means that the most frequent item appears roughly twice as much as the second most frequent, and 3 times as often as the third, and so on. Where do we see this? In language. For example, the letter E is the most common letter, followed by maybe S. A, probably.
Just throwing it out there.
Yeah. But it'll be used twice as much as A. And A will be used twice, or the third letter will be like 1/3 times as much.
Why wouldn't it continue exponentially?
So it sort of is exponential in a way. It's logarithmic. It's not really exponential. I think they're sort of different.
Okay.
It's not constant. It doesn't. It's not like the letter E is used. I don't know, 99%, and then the next letter is used. Like 33%. Then the next letter is used is 32% and 31%. Those are also bad numbers because they don't add up to 100. Okay.
Wait. So let's say it's EASI. Okay. So E is used twice as much as A.
Yeah. Or how I think of it is like E is used 50% of the time, something like that. A is used 25% of the time. S is used 12.5, and so on. So there it is exponential, but it's also it's not exactly half, but it's inversely proportional. It could be like a half and then a third and then a fourth and then the frequency of how often it comes up, and then you have to normalize that by all of the to make sure that it fits into 100%.
Okay, fine.
But the point is that, the word "the" is the most frequent word in the English language. And it's used so often, it's not just like used a little bit more often than the second most used word. It's used a lot more often.
Mm-hmm. Just to say that "the" is the most frequent word in the English language, you use the word "the" 3 times, not including when you cited the word "the."
Nice. So that's just a law, though, and because it's a law, it follows the same reasoning. It's not really a scientific law because it's not consistent across all of the anything you use, and it's not true always. But it's an observation that holds for a lot of phenomenon that we see, and that's all that a law is. And there are explanations for it. There's the principle of least effort, and that it's easier for speakers and listeners to reuse the same words more frequently rather than use many different words, many different letters. It's better to converge and use a lower amount of words more often. Obviously, we still need some diversity. We can't just use the letter E to express everything, because if you want just to use the amount of times you say E to mean something else, like 2 E's means a different word than 3 E's, you lose variation, and all of a sudden it becomes much more complicated to say many different words. You have to use a lot more E's, so then it becomes inefficient again. So there's an efficiency balance between variation of letters, but also reusing of letters. And that converges on this type of distribution that is more logarithmic.
But clearly not everything follows this law, right?
Yeah.
Okay. Like there are plenty of things that the most frequent thing doesn't appear twice as often as the second most frequent thing. It's hard to think of an example right now.
Right.
Baby names.
I mean, but the law of gravity, in a way, it also doesn't apply always because of air resistance and stuff. So it really is being applied. It's just the air resistance is negating it.
Yeah, those two things are not comparable. The law of gravity is still there. There are other things affecting the speed or the trajectory of the object. But this Zipf's law thing, it seems more like a statistical distribution.
Mm-hmm. So I will tell you, Newton's laws of motion also are just not true in certain circumstances. They break down at high velocities and with very small atomic objects. So they just don't apply. So even though it seems it's more of an illusion that Newton's law is more consistent than Zipf's law, there are still circumstances where it just doesn't hold up.
Well, so super small objects, that I can kind of classify as it's the inner workings of the black box. What I mean by that is I'm a software developer. So you can have a computer application made up of modules. And each module has a very strictly defined behavior and a strictly defined interface. And you can very coherently think about the behavior of the system just in terms of the behavior of the modules, and you would be correct. But your understanding would break down if you then go inside the module and you understand how each module works. So in other words, the implementation details of the module. And so your understanding of the system would then become insufficient. But that doesn't mean that it was wrong. If you just stay in that in that particular level of complexity, where you were thinking about it in terms of modules, you were correct in how every module behaved. So maybe Newton's laws of motion are like that.
Okay, so Zipf's law applies in the module of language.
But this isn't a level of complexity in the general hierarchy of reality. This is one incident. It's not all modules at this level of complexity. It's one particular module. It's different.
Okay, so Cal maintains that it's different, using his analogy of modules. I hear what you're saying, but if we're talking about universal laws, then it's got to apply for everything. But that's the point. That's the point exactly, that our understanding of laws are ultimately just in specific, cases based off of observation, that we try to build from those laws a larger unified theory to explain why they happen. Because once we know why they happen, we'll be able to say, oh, that's why that applies here. That's why that module works here. But ultimately, everything, all the modules follow one specific theory, one grand theory. So the more you understand about why it works, the more the implementation details don't matter and become irrelevant and can be applied across everything. So speaking of theories and what they really mean, theories take observed laws and explain them, like we said. It explains them deeper. So it's still a bit subjective where to draw these lines, where to draw the module, like what defines a specific module or field. So you have, for example, the theory of relativity, which is Einstein's explanation of really how movement, mass, and acceleration works. And it explains it all on a much grander level. It explains it also for objects at a high speed, high relativistic speeds, meaning close to the speed of light. It explains how those behave, which is something Newton's laws couldn't do. There are still issues that Einstein's theory don't explain, why things happen at a very small level, at a quantum level. So there's still inconsistencies, but we call it a theory because it provides an explanation, a model of the universe and how everything works, how matter really works. It's not just a constant number. It's not a simple relationship. It's really what explains what space-time and matter is, what it consists of, and how matter is equivalent to energy, and how speed enters that equation. That's the whole E equals mc squared thing. So it just explains it at a different, deeper knowledge. And ideally, theory should be able to make scientific theory should be able to make predictions about unobserved phenomena. So laws are, you observe the phenomena, and then you create some sort of mathematical relationship with this table of observations, let's say. But theory should say, I know why it works in that case. I can explain that. And it works so well that I can now make a prediction on a totally unseen thing because my explanation is so good. So Einstein's theory of relativity was able to, for example, predict gravity waves, which is the wave of energy when two supermassive neutron stars or black holes are colliding. And this was something that should exist within his model if you follow his math. No one had ever observed these things because we didn't possess the technology to do so. His explanation was so good that we were able to confirm that gravity waves do exist 100 years later.
Mm-hmm.
As well, following Newton's laws, we wouldn't have been able to predict gravitational lensing, meaning light bends around massive objects on Earth. Bends around massive objects like the sun. So if you are observing a solar eclipse, there should be not an inconsistency, but it won't happen at exactly the same time when something is passing, when light is passing through the sun or around the sun. It's going to be bent. Newton's laws don't say anything about that light would bend, but they were able to, after Einstein came out with his whole theory, they were able to observe. Some guy went on an expedition to the Pacific to observe how light bends around the sun during a solar eclipse because of following Einstein's model. So it's just an example of like, even during Einstein's time, they were able to confirm it.
We don't mean the moon here, because the light is coming from the sun.
Sorry, yeah, the light is coming from the sun. It was observing the light of a star, a distant star around the sun, which is massive.
Uh-huh.
The moon wouldn't be massive enough, but the sun is able to bend it, but we can only observe the light of a star during a solar eclipse because that's when it's dark enough. Usually, so the moon was just used to limit the light coming from the sun, so that we could see the light from the star behind the sun being bent around it. We shouldn't have been able to see the star because the sun should have been in the way, but because it acts as a gravitational lens, it bends this light from around the star.
Very interesting. Did this require the moon and the sun and this other star lining up in some coincidental way?
Yes. So this had to be a star that was unobservable, in general, because it's behind the sun. Knowing, where the stars are, they're very set in their. I mean, they change over a scale of millennia, but where a star is going to be very consistently over the next, thousands of years.
Mm-hmm.
So they knew where the star would be, and they knew that it would be behind the sun and invisible, or concealed by the sun. And they knew that there's going to be a solar eclipse at this exact time, and the star is going to be located right behind it. So they needed to do all those predictions. And according to Newton, you wouldn't have been able to see that star. According to Einstein's theory, you would.
And we did.
And they did, while Einstein was alive, so he was vindicated while he was alive even.
Mm-hmm.
His theory was able to make these predictions.
Mm-hmm.
There's also the theory of evolution, which is organisms with traits better suited to the environment tend to survive and reproduce more. And I don't know, in my opinion, that's it's a theory because it explains why, certain traits pass on. But it's also like a law because you kind of look at the animals and you observe that, hey, there's certain, spots on a leopard or giraffes have taller necks because they have to be able to reach food. It's kind of like this self-referencing theory and law that you're saying, you assume if they're alive with these traits, then that must mean that they're better suited for their environment because of it.
I think maybe the law tends to go by a different name. Oh wait, no.
The law of fitness.
I just googled something else. Is it the law of natural selection?
Oh, maybe. Okay, so the law of natural selection is a law because
meaning it's the theory of evolution is the theory because it explains how species evolve over time. A core thing
principle,
inside the theory of evolution is the law of natural selection,
which says
that individuals with traits better suited to their environment are more likely to survive, reproduce, and pass those advantageous traits onto their offspring.
But that sounds almost identical to the theory.
Well, the theory, I think, would speak in more general terms and say that this law was at play over the course of the history of animals, and this resulted in, the various species that we see and their genetic nature.
Mm-hmm. Okay. I mean, it still to me sounds pretty much like it's saying the same thing. There are also other issues I have with the theory of evolution.
Whoa.
Okay. That came out wrong. I apologize. Of course, I believe in evolution. What I mean is...
But we should talk about that.
But we should talk... sure.
But yeah, finish your point.
My point, and it's not Cal's disbelief of evolution.
I didn't say that yet.
Right. No one said it yet.
No one said it yet.
Allegedly. My point is that, let's say I see something in nature, then usually there's this retroactive way of reasoning to say, because it exists, I could come up with some explanation for why this must be like a superior trait and better for survival. I mean,
there's a is it selection bias?
Yeah, or something like, I don't know why men never ask for directions, and then I'll say, oh well, it's because back then, they needed someone to take the reins, and it's if you defer to someone else, then you lose your status on the social ladder. But at the end of the day, it's just me kind of making this up. It's probably true. I think it's true, but it's not very scientific because there's no real way to falsify it. There's no real way to say, like, let's take a bunch of people and, see what happens when they don't ask for directions or something. It's not as hard as science. It's not...
Interesting. So it's a little hard for me to it's hard for me to separate this conversation from a conversation about God, because one of the arguments for God that sometimes people make is how adapted we are to our environment. That there are things that our body does that help us survive. And it's like, wow, if our body didn't do that, we wouldn't be able to survive. And if the environment wasn't exactly the way it was, we wouldn't be able to survive. And there's so many things that have to line up that allow us to live on Earth, and also the animals as well. And evolution comes along and says, well, the reason why we seem so adapted to our environment is because over many, 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 many years, the environment produces organisms that are adapted to their environment because they are the organisms that survive. We simply don't see all of the organisms that are not adapted to the environment because they are dead.
Right.
So, but I don't think that is to say that every single aspect of us is adapted to the environment, as if all of us we all just sort of immediately gravitate towards optimal existence.
And even according to evolution, there still are random mutations. Mm-hmm. Looking at the DNA of a person, there are parts of it that just don't do anything. There's strands that have no expression in any positive or negative way. And yeah, even evolution would agree with that. Like, that's part of it. Mm-hmm. But the fact that we can know and decide which ones are necessarily good and which ones are necessarily bad, it's just very difficult to do, even from like using the scientific method. How do you how do you prove that something isn't evolutionarily advantageous?
I don't know that you can, and I don't know that you would need to. Why do you need to prove that something is evolutionarily advantageous? If it is evolutionarily advantageous, it'll stick around. If it's not, it won't.
Well, not necessarily as well. I mean, there could be
externalities.
Yeah. Or
Like
it could be like
meteor storm, meteor strike, or something.
Sure.
Sorry,
but I don't know. I just meant that you could have something that turns out to actually be bad for people. Like maybe a short term it's positive, long term it's not, or it's just coincidence.
Well, I mean, I also don't think evolution claims that it kind of linearly improves, like everything improves linearly over time. If there is a mutation that is short term good but long term bad, it'll survive for a bit until it doesn't.
Right, but then you're just kind of left with this hodgepodge of what is good, what timescales are we talking? Like, what we need to be able to determine what is considered a more fit trait over another in order to make use of this theory of evolution.
So the goal is to make use of it for practical purposes right now.
Not just practical purposes, but to even like understand it and observe it. Like you don't have to, not just to make use, but to look at evolution and to look at animals and say, there it is. That thing I could say is an expression of evolution. It's there. I see it in action.
Maybe evolution is not falsifiable.
So maybe. So I'm just saying that's what like some of the there are people I think that have a lot more philosophical issues with evolution, but it still explains. It's the best model we have to explain why giraffes have long necks.
If we're adamant to not hypothesize God.
Yes. If we
assume a physicalist worldview, evolution might be the best explanation we have.
Right. But I'm a little scared to ask.
Well, you seem to be speaking in such a way that
all right.
You were comfortable with yourself speaking as if like evolution. Maybe it's not so.
All right.
Not so clear cut.
Well, but not on. Okay, fine. Cal, do you believe in evolution?
Well, we have to define the question.
That's hard.
That's hard. Do I believe in evolution? Well, I think it's clear that mutations occur and species evolve to a certain degree. And the law of natural selection, I think, makes a lot of sense. I think that if you have a species that is undergoing mutations, the mutations that will be beneficial to that species will be the ones that last, and the mutations that are not beneficial will be the ones that don't.
It's very logical.
It's very logical. I mean, you certainly have to. You then have to add in sociological factors because animals create cultures among themselves, not just humans. And those things, it's not clear that those things, just because a generation of mice have learned a new cultural norm of some sort that was beneficial to them, it's not clear that necessarily is propagated to the next generation. So as soon as you have cultures formed between animals, you clearly have a number of other forces at play towards that species evolution that are not just the law of natural selection. But that doesn't mean that the law of natural selection is not a thing that occurs. Like that sounds like that's something that occurs. And what I'm getting at is that if you gave me a species and you asked me, is it possible for this species to change in some way over time, and maybe in some way that is beneficial to them, I'd say, yeah, that seems plausible. But if you then made the claim that all of life is explained by this, I immediately raise my eyebrows. First of all, it doesn't explain how life actually began. How did we get the first organism? And also, it seems a little...
Which is something that science still doesn't have a satisfactory explanation for.
Okay, very well. And also, it seems a little implausible that what did we get? One organism, one little one-celled organism. That was the first thing, and then it is like the father of everything, and it eventually mutated and created other organisms, and this all eventually became the diverse animal kingdom we have today.
It does sound very improbable.
And also, how long was this supposed to have taken? Right. Okay. So sometimes the response is, well, listen, you can't wrap your head around how long this was occurring. Like, who
3 billion years.
3 billion years.
Life started, maybe it's 4 billion.
So I would like to offer that is a surprisingly low number. When you hear the theory of evolution and you start asking questions like this, like, wow, like it all just naturally occurred from like the first life, and these mutations occurred with the environment, and we got from a cell asexually replicating itself to diverse species sexually reproducing, as well as
unicellular organisms becoming multicellular organisms.
Yeah, even just that as well.
But that's documented. Yeah.
Okay. But
like it's we have the records that they exist. Unicellular organisms existed before multicellular organisms. So there was a jump, and it took a long time.
That doesn't mean that one became the other. One simply existed before the other.
Right. I suppose.
Okay. So anyway, when you start asking questions like this, the response seems to be, but dude, we're talking about an enormous amount of time. In that amount of time, you just can't wrap your head around, like, yeah, that's, you just can't wrap your head. But then an
enormous scale of like, it is extremely improbable, but there are also billions and billions, trillions of planets and planetoids, where, which were part of this lottery. And obviously we're not going to be there because we're going to be here to observe it. So because we exist, because we're life.
Okay, so let's focus though on our planet for a second and the amount of time. Like I was in the middle of a point there because I was saying that, okay, it sounds like this is a little implausible, like how all this happened naturally. And then they say, well, you just can't wrap your head around how much time we're talking about. And then you're like, well, how much time are we talking about? And then you say 3 billion years. And I'm like, that seems like an incredibly low number for what we're talking about. Like, there are people on Earth who have more dollars than that. Like, 3 billion is not a large number. I'm sorry. It's definitely a number that a number that you can wrap your head around.
Well, the thing is, I've actually seen, like comparisons of $1 million to $1 billion. Like, $1 billion can wrap around the entire Earth 3 times.
Okay.
$1 million can, like,
the Earth isn't that big. We can fly. We can fly halfway around the Earth in 12 hours, 16 hours.
Okay.
Right. You can wrap $3 billion around the Earth. We're talking about evolution here. Like, I'm
3 times.
3 times. Like, the Earth isn't that big when we're talking. With the scale we're talking about, 3 billion years sounds incredibly small.
If you're assuming just random atoms,
just completely random,
rearranging themselves
out in nature
until they magically form the pattern of a cell, yes, that would be 1 in 1 billion to the billion or something. Is that, or no? It'd be less, because we said there's only 10 to the 53 atoms in the universe. So if you take all permutations of that, that's probably only gets you to like 10 to the 70 or something.
Okay. I'll take your word for it.
But so point is, I don't know what's larger, 1 billion to the billion or 10 to the 57.
Definitely a billion to the power of a billion, or 10 to the power of 57, which is larger.
Never mind. Yes. Okay.
Why did you say 1 billion to the power of a billion, though?
Because that's what I said in the first place.
Okay.
But 1 billion to the power of 20 compared to 10 to the 57. 10 to the 57 is obviously Way bigger.
I think, yeah, that sounds right. Usually the one with the higher exponent is often
Yeah.
bigger because exponents.
So yes, if we just assume that the molecules assembled randomly, then yeah. So I get what you're saying, because it is truly, if we assume random permutations of atoms, 3 billion years is not long enough.
Mm-hmm.
And what scientists will do is kind of use this backwards working logic, not backwards logic, but it working a little backwards, that we assume, because everything else can be explained through scientific law, because cells evolved, we have evidence for how cells evolved to be more complex and more complex over time, then although we don't have the answer right now, we assume that it just started from something even simpler than one cell, one reproducing asexual cell,
Mm-hmm.
and that there is some sort of chemical process that arranges itself into the parts of a cell, or something simpler that can then evolve into a cell, and we just haven't found it or figured it out yet.
Mm-hmm.
And I will give you some points on that, saying that, agreeing that it's a little sketchy, because we haven't we haven't come up with an explanation yet that it automatically means that we will come up with one. But to me, it seems that it's more likely that we just haven't come up with it yet, because you said 3 billion years was too short.
Mm-hmm.
Scientific method and scientists have only been researching this for 500 years, I guess. The origins of life.
But
so give it 1,000 years.
that's a really long
what
time when you
will-
consider there's such a difference between things naturally occurring randomly in nature versus human intervention. So it seems to me that actually, if evolution was solely responsible for the development of life and the animals and us, and all of it happened in 3 billion years, it seems to me quite clear that human beings, scientists in a lab, whether for 500 years or even for just 50 years, in 50 years in a lab, being able to simulate natural selection however many times you want, using whatever metrics you want to select, meaning you can now optimize selection for survival and for greater, not just survival, but thriving in the environment. You now no longer just rely on the.
Are you talking about genetic engineering?
I am talking about
genetic modification,
whatever you want to call it. But no, not just genetic modification. I'm just talking about
GMOs.
No. I'm not talking about that specifically. I'm just talking about having a bunch of fruit flies or bugs or even just cells in a lab, having a bunch of them, having them replicate. You can even select the ones that are best for survival.
Well, that's what GMOs are, from my understanding. It's not going in and splicing the DNA. It's taking like vegetables and then seeing which vegetables, let's say it's tomatoes, look the best, because each time, there are little mutations. And so if you see, oh, this tomato you're going for a smaller, plumper, sweeter tomato, like a cherry tomato, then you keep just breeding the tomatoes that look more like your final end goal.
Okay, very well. Yeah. The point is that you can now control the process. You can simulate the process. You being scientists, whoever wants to.
And they've been doing it with dogs for thousands and thousands of years.
Oh, yeah, exactly.
That's how they breed different types, yeah.
Nice, yeah. But we don't see the level of evolution that we would expect to see given our efforts at doing this. We see limited evolution within a species. We haven't replicated large-scale evolution into an entirely different species, or even just replicate what we believe happened, from one smaller species to another more complex species.
Well, we don't have the time to do such a thing.
We shouldn't need nearly as much time. And by nearly, I mean we should need a small fraction of the time that it actually took.
Like, you want to evolve a chimpanzee into like a thinking.
If this really happened, we should be able to replicate it in a lab.
Even if it took billions of years.
3 billion in nature. It should take 50 years in a lab.
I think that's a bit of a fallacy. A very large fallacy. But I get where you're driving at.
Like, here, there's a cycle that this conversation seems to take, and I go back to, because evolution often comes up with conversations about God. So, like, a religious person might look around the world and he'll say, "Wow, look at this beautiful world. It's like, I need water to survive, and look, there's so much water. I need air to survive, and look, there's air. Like, it's as if the world was created for me." And then the skeptical biologist comes along and says, "Well, okay, this is how evolution happened, and like, this is how it all naturally occurred, and like, you just happen to be here because you had the right mutations that allowed you to survive in this environment, and that's why you're here, and that's why you're appreciating it." And the religious person kind of gets a little downtrodden. He's like, "Oh, all that meaning that I thought I was getting from the world, all that beauty. Okay, it's all just random mutations in the end. How long did this?" But then they might say, "But there's no way that all of what we're seeing could just happen from random mutations, right? There's no way. That's so implausible." And then the person says, "Well, it took billions of years." And there's, "Well, how long?" And then the person might say, 3 billion years. And it's a cycle, because every explanation that the skeptical biologist gives to the religious person just reinforces, "Oh, it's different than the way I originally understood it, but it's still miraculous. Like, you're telling me all this occurred in 3 billion years through random mutations? Obviously the work of God."
Okay, so a few things there, and then maybe we'll
wrap
it up for part one.
Okay, sounds good.
First things first, I think we are able to, and I've done this, in software. You can do small scale replications of evolution. You can make, they call it like a 2D automata, which it's basically a grid, the game of life, where each cell follows certain, like 3 simple rules. If it's each cell is either alive or dead. If it's has too many neighbors that are alive, it dies of overcrowdedness. If it doesn't have enough that are alive, it dies of loneliness.
Okay.
And you just keep iterating and running this simulation. And then all of a sudden you get all of these, you start it randomly, and you get these interesting, complex organisms that arise. You have gliders that fly across the screen. They have shooters that shoot, little particles out every once in a while. So you have this complexity that arises.
Mm-hmm.
Obviously, it doesn't exactly mimic real life organisms, which are way more complex. The second point is, I'm glad that, I didn't know if it was going to, that the devil put the fossils in the ground. So obviously you're not arguing that. You're not.
No.
You're giving credence to the theory of evolution.
Yeah.
But you're emphasizing that there are certain issues and holes in it that that science hasn't yet explained, and scientists just assume that it will get explained, when they don't really have a solid basis to assume that. They're just extrapolating based off of other fields of knowledge.
And mainly what I'm saying is that when a person tries to use the theory of evolution as a rational, natural explanation for the origins of life that doesn't need God, it actually becomes a very implausible theory. But if said as this is the way life developed, and science won't make a claim about God, that's fair. But maybe when I say this, I'm talking to religious people. Religious people should be able to say, like, yeah, if the current science suggests that life develops through the process of evolution, sounds great. It still seems that was created by God, because that still seems like something very miraculous, right? It's not really any less miraculous than life just kind of appearing. It's sort of like the miraculousness of life is dependent on the fact that God created it instantaneously. That's what was miraculous. God creating it over a fairly small amount of time, relatively speaking, to what was occurring, still seems to me to be perfectly sound, perfectly coherent religious thinking.
Mm-hmm. So that was my third point was, yes, if you want to, look at it as miraculous, which is subjective, then you're fully within your right to, look at it and say, wow, this is amazing that, God created this theory of evolution. It's so great. And now I even get to appreciate it even more. And which is kind of in the line of the scientism, or whatever it's called, types of people like Neil deGrasse Tyson that, just believe that there's the beauty in understanding more about science is just will give you this pleasure and appreciation for the world.
Mm-hmm.
But what he would say is that the field of what religious explanations give, and the field that it existed that consisted of religious explanations slowly recedes over time as science expands. And so it used to be that, yes, indeed, people believed in this instantaneous religious explanation that God created man on the seventh day, the birds on the sixth, or whatever, or man on the sixth, birds on the
fifth, fourth, fifth,
and then
fourth.
And then,
no.
Once evolution came along and explained, no, this created this, and then once astronomy and physics came along and said, no, the moon existed for this many years. So then religious people, the explanations took a step back and said, oh, well, that's okay. It doesn't have to be instantaneous, or, as long as the moon was created at one point, then it's all good. I still see the beauty of God, which is fine. You could do that. But then eventually, how far is this, are these religious explanations going to go until they literally, all that's left is God, nothing else, some prime, unfalsifiable theory of religion. And then what does religion come along to do in terms of explanation anymore? A lot of that seems like it could be maybe even tossed out, and then what you're left with are your personal, societal values that come from religion. But religion as an explanation for how things exist has receded into nothingness.
Depends what we mean by an explanation for how things exist. We might have to cover that in the next parts, but yeah.
Because just to give a little sneak peek and something for our viewers to think about, if science, explains and theorizes how things work in the world, well, religion does that as well. What, besides the method part, why, what are the essential differences between, let's say, Aristotle's theories? Those were also explanations, the fire, earth, wind, and water. Those were also providing explanations.
Yeah, but I don't accept that there's a parallel way of thinking between religion and science. It's two very different ways of thinking, and both are good. Well,
that was supposed to be for the listener to
think about. Okay, I am the listener.
He is the listener. He's stealing your homework. He wants to do it for you.
No, fine. I gave my own answer very briefly. That I don't really see the parallel that there's religion does the same things that science does. I think they do very different things.
Mhm.
Also, in next part, we will actually explain what J.S.Lee Peakman means when he says "science, bitch."
We will?
I think so.
Okay.
We didn't do it this time.
We didn't?
I don't think so.
Well, okay. My explanation was that.
Oh, fine, we're doing it this time.
Well, I just thought we covered it, that it was, look at, look at the power of science.
You did mention that. No, that was good. That was good.
When it's just like, it's not actually science. It's just, he's confusing the method for the culture of science, or the technology that science has created.
Oh, I see. I hear that. But actually, I would maybe give him more credit. I kind of tried to talk about kind of like the fundamental force behind scientific thinking when we started, that it's this curiosity, it's this desire to know, and science is the disciplined pursuit of knowledge, I called it.
But that could be applied to religion as well. You want to know God. It's very disciplined. It's very...
Well, actually, yes, you're right. But you're knowing different things there. When knowing God in a religious sense versus knowing how the world works. Actually, Rabbi Joseph Soloveitchik talks about this in his book, The Lonely Man of Faith. He talks about there's two... Did you ever read this book?
No, but it has a lot of big words. And if you could get through it, you're considered a smart person.
I got through it.
Nice.
It's not so bad in terms of the big words once you get going with it. But I think he talks very wisely about there being two kind of personalities in each of us. One he calls Adam the First, because he's using Adam from the Bible as his reference point. One is Adam the First, and Adam the First is interested in essentially conquering the world, harnessing the world to his needs and interests, and that involves very much scientific pursuit. And that's so when Adam the First wishes to know, right? When he sets out to understand the world, he seeks to understand how it works so that he can harness it as a tool for his interests and his achievement. When Adam the Second looks out into the cosmos, he is examining it from a more he's not asking how it works. He's asking why it exists at all. He's asking what is his relationship to it. He's asking what does it mean for his existence and for his significance. And so when you say the religious person seeks to know God in the same way the scientific person seeks to know how things work, but they're seeking to know two very different things. And I think it's very much what you just touched on. It is very much what Rabbi Soloveitchik gets into in The Lowly Man of Faith. I hope I've summarized it at least somewhat effectively just now.
Mm-hmm.
Yeah.
Okay, so we'll pick up from that in the next episode. We'll also discuss all sorts of branches of science, what we think about them, more of a history of science from beginning all the way back with maybe the invention of fire. Okay. But until like contemporary science, 1500s.
Uh-huh.
And then we'll really get into deep philosophy of science issues, like when you look at it and really take apart science and the philosophy of science, there are some very deep intrinsic issues, not that don't negate the method or anything, but that really make you question how you can make it systematic and consistent throughout. And we'll discover that you can't really, there are a lot of assumptions that it's based off of, and we'll delve deeper into them.
Mm-hmm.
All right. Well, we're still very thankful to what science has achieved.
Certainly.
And we would not be able to be talking to you right now without all the inventions that came from it. So we wish all of you a very pleasant night. And yeah, science, bitch.
All right.
This has been the Benjy Cal Podcast.
Good night.